Hello there, my name is James and welcome to this Backend Full Course where we're going to go from being complete amateurs at backend development to absolute pros building all sorts of amazing backend applications for the internet. Now I am very excited to have this course live on the channel because I personally know how hard it can be to learn the art of backend development. I went through that on my Learn to Code journey, and now I'm very excited to have this course available because ever since that experience, I wanted to create a course that does three things. First, it's super beginner friendly, which means that even if you have absolutely no experience with backend development, you will be able to complete this course. We'll start from the very beginning, from scratch, and build up from there. The second thing the course does is it teaches you all of the core concepts and foundational knowledge you need to know, all of the best practices, the latest and greatest technologies that you need to know to go off and become these supreme wizards of backend development. So that should be super cool. And last but absolutely not least, if you get to the end of the course, you will be left with a portfolio of projects of the caliber needed to get you hired as a full stack developer, backend developer, software dev, you name it. These projects in your GitHub will knock the socks off prospective employers, your family and friends, and it will just be loads of fun. Now the course itself is broken down into 4 chapters. Chapter 1 is a theory lesson where I want you to sit back and open up your brain to the universe as I share with you some theory about how the internet works, what the full stack is, and consequently what the backend is, what we can expect from it, and how we can actually go about coding out some backend infrastructure. Now, this is not for you to sit down and memorize everything that I'm saying or take some notes. It's just an exercise in gaining some familiarity with some of the concepts that we will then put into practice in the latter 3 chapters. In chapter 2, project number 1, we're going to build a very rudimentary backend application that just demonstrates some of these core concepts in code form. Pretty simple, doesn't look the best, but it serves a purpose as it allows us to dive into the last 2 projects, which are super cool. Project number 2, chapter 3, is a complete backend application. It's kind of like a quick start backend application where we develop a very comprehensive backend server and have complementary database interactions. We'll be using the SQLite database, which is a super lightweight, fast to get up and running database, very popular. Maybe not so much for production, but if you're just looking to get your backend application up and running, it is a great choice. So we'll learn how we can develop a backend application that serves up a front end, uses authentication, and has database interactions. And then in the last project, we'll take that code base to the next level, God tier mode. We're going to be using Postgres for the database. We're going to be using an ORM, which is an object relational mapper, and that's going to be Prisma. We'll serve up a front end. We'll handle all of the authentication and database. And then at the end, we'll Dockerize all of these backend services so that we have this containerized application. It should just be absolutely wicked. A brilliant code base to have on your GitHub page for, once again, prospective employers to have a look at and be like, yes, this is the person we want to hire to develop our backend infrastructure. Now, as for the prerequisites, what do you need to know to complete the course? Well, the list is pretty short. All you need to know is some JavaScript. If you're looking for a course to brush up on your JavaScript, I've got one linked in the description down below. But everything else you need to know in this course will be taught to you. So you just need some pretty, reasonable JavaScript skills and you will be absolutely sweet getting to the end of the course. And last but not least, what do you do should you get stuck at any point? Well, I've got you covered there too. First up, we have some cheat sheet notes. You can just keep these open if you want. They're available for JavaScript and they just cover all the basic JavaScript techniques that you should be aware of, linked in the description down below. And as for any questions, qualms, or queries you may have, if you head over to the GitHub page for this project, that has all of my code there that you can look at and compare. And with all your questions, you can head over to the Issues tab, click on Issues, and then just write your question and either myself or someone else will respond and help you understand whatever it is that you may have been struggling with. So that should be absolutely wicked. Finally, if you want to support the channel, you can obviously become a channel member and unlock the Discord where I'm super active so you could ask any questions there too. At the end of the day, it should be an absolute wicked course. I've been so excited to release it. I've worked on it for ages. So proud of this material, and I hope you thoroughly enjoy it. And with that all said, if you do enjoy the course, don't forget to smash the like and subscribe button so that I can continue to feed Doug a healthy diet. Alright, it's time to dive into Chapter 1, which is a theory lesson about how the internet actually works. Now, as I said in the intro, I don't want you to take any notes. I just want you to sit back, get comfortable, and be a sponge for the information that I am about to share with you. You don't have to memorize all of it. I just want you to be familiar with some of the terms and concepts so that when I refer back to them later in this course, you can be like, I know exactly what's going on here. And the first concept I'm going to introduce you to is known as the full stack. Now, when you open up your computer, load up a browser, and come to YouTube, essentially the programming that goes into creating that experience is known as the full stack. It's the overarching body where the culmination of all of these individual puzzle pieces working together to create that experience. It's kind of like a burger. A burger is the end product, just like you loading up YouTube.com. That's the end product. You experience YouTube. And a burger has a whole lot of subcomponents that together create this experience of enjoying a burger. And that's the same with YouTube. A programmer, or lots of programmers, have sat down and worked together in creating all of these puzzle pieces that come together to creating your experience of YouTube. And as a collective, they are referred to as the full stack. It's the full stack of things coming together to create that experience. Now, the full stack can be broken down into two primary components. One is known as the front end, and the other is known as the back end. Obviously, this is a back end course, but to understand what the back end does, we also have to understand what the front end is responsible for. Now, the front end kind of is summarized in three core concepts. One is the user. You, using YouTube, are a user. We've all got experience being a user. The second concept is known as the client. The client is the medium through which you interact with the internet. In most cases, it's a browser. So Google Chrome would be the client through which you interact with the internet. Whether that's entering a URL or clicking a save button on a website, that's all a client-side experience because it's happening on your device. It's on the side of the equation that is associated with the user or the client. Now, the last term that comes together to create the front end is actually the front end itself. What is the front end? Well, at the end of the day, it's pretty much just the website. So when you load up youtube.com, at its core, that's some HTML, CSS, and JavaScript that your browser runs to create this visualization of the website. And that is referred to as the front end. So if the client is the medium through which you interact with the internet, the front end is the legitimate interface that you can interact with to have this internet experience. And so that is the side of the equation that is the user side. It's on the user's device, and that collectively creates the front end. It's the tangible side of this full stack experience. Now, at the same time, when you load up YouTube, you're probably connected to the internet. What's going on in the background to facilitate this experience? Well, the answer is a lot of stuff. There is so much magic going on behind the scenes to create your front-end experience that without it, you just wouldn't be able to enjoy the internet. And that's what this course is all about. How can we program these systems? Now, the way that I want to describe how the backend works is actually by step explaining to you what happens when you open up your computer, load up a browser, and enter www.youtube.com, and in a split second, get that website displaying on your screen. And essentially how it actually works at a very technical level is that when you type in this URL, www.youtube.com, and hit enter, your browser sends out what's known as a network request. Now we can imagine that your computer doesn't have every single website on the internet saved on it. So that means that when you load these websites, your browser is actually having to request these websites from an external network. Now, there's loads of examples of what a network could be. It could be a cellular network for mobile phones. It could be a Wi-Fi network or a LAN network. There's lots of different examples of networks, but essentially your browser, when you type in and hit enter on this URL, your browser emits this electromagnetic wave that is encoded with the information that your browser needs access to. So it is encoded with the URL. The network request has this URL saved into it. And then it emits this network request into the network where the URL actually locates a destination. Now, a lot of us might actually think of the internet as being this ethereal thing that exists around us. And, we magically pull the information out of the air when we type in these URLs, but actually it's slightly more complex than that. The URL, a lot of people might not know this, but it actually is an address. So when you type in www.youtube.com, your network request is directed to an address in the network. And that address doesn't actually locate a website. It actually locates another device connected to the internet. Now, every device connected to the internet has what's known as an IP address, and that is its metaphysical address in the network. So when we encode these addresses into the network request, the network is set up to navigate and ultimately locate these devices. Now, a URL is just a human-friendly address. So every device connected to the internet has an IP address. Not all of them have URLs. But when you type in a URL, that gets converted to an address via what's known as the DNS, which is the domain naming service. The domain is the sub-portion of the URL. So in the case of www.youtube.com, the domain is youtube.com. That gets converted into an IP address, which is a sequence of numbers. Not very easy to remember, which is why we have a URL. And that's where these network requests get directed to. They get directed to these addresses, these IP addresses in the network, which are corresponding to another device connected to the network. Now, that doesn't really explain how you end up with a website on your screen, but we will get there. These devices at these IP addresses are set up to listen to incoming network requests. So when we develop servers like we will do in this course, we set them up, we connect them to the internet, and we set them up to listen to incoming network requests to their IP addresses. Now, when a server receives our network request, which is asking for a website, if you've entered the URL www.youtube.com, it can then decode that network request, see that, this individual is looking for the HTML code to load up the YouTube homepage, and it can then go to its little database where it's stored all of this code or read some files that are available on this external device, and it can then encode them into a response. So these network requests that these servers receive also have a return to sender address. So they interpret the intent of the network request, they do any actions that they need to, and then they respond with the appropriate information, data, or service. And that all happens in the split second that it takes to load a website like youtube.com. You hit enter on that URL, your browser emits the network request, it's encoded with all of this information that describes the intent of that network request, which in the case of entering a URL is to retrieve a website or gain access to a website. It hits this server, and then the response is sent back across the network as literally electromagnetic waves, whether or not it's through a fiber optic cable or, the air. Your browser receives this response that is encoded with all of the appropriate information. In the case of a website, it's HTML code. It then interprets the HTML code and displays it on your screen, and you get the website. Now, that is a full stack interaction where the moment the network request leaves your computer and goes into, the ethos or the network, everything on the other end of that equation is the back end. The back end is all of that code that goes on behind the scenes, potentially on other devices all around the world, to facilitate your experience of the internet. If we didn't have back-end applications set up to listen to these incoming network requests, there would be no websites to load. It would just be, you'd send out a network request into oblivion and you would never get any response back. And so that's what we're going to be coding in this course today. There is so much you can do with backend applications, and we're going to get a really solid understanding of some of the most core operations that you can expect from backend applications. Now, there's two more things I just want to throw into this theory lesson at the very end. Number one is what the front end actually does. I've talked about that entering a URL sends out this network request to gain us access to the HTML code to display the website. Well, the website itself is typically just an interface to make sending out these network requests even easier. So when you hit save, the same operation occurs to persist that data in a database. A network request is sent out saying save this information to the database. The server, listening for these incoming network requests, receives the network request, interprets that, oh, the user wants to save the data. It then might even send out another network request to the database with that information, and that then gets persisted in the database. So the backend can be, a whole lot of separate servers interconnected to facilitate your experience of the internet. And the other thing I wanted to point out is that, nowadays we have a lot of modern solutions for developing backend applications, such as cloud infrastructure or serverless backend infrastructure. All of this is just more servers running more code set up to listen to incoming network requests. So at the end of the day, the full stack is just the front end, which is on the client side on your computer where the user interacts with it. They get access to a front end. And the back end is everything that happens server side, where the server is all of these external devices all around the world, and they communicate through a network via network requests, which are encoded with all of the information that allows that communication to happen and for both parties to contribute to someone's experience of the internet. Now, I know that's a lot of information to swallow. Once again, you don't have to remember all of it. Just being familiar with the concept of a backend. Okay, it's this external device that's connected to the internet that's listening to incoming requests sent to its IP address. A URL is just an IP address that's written in a human-friendly form. The client side is everything that happens on the user's device. The client is the browser, the front end is the website. They are the user. Just being familiar with these core concepts will really help give you a solid foundational understanding of all of the decisions we make throughout this course and just make you that much better of a back-end programmer. Anyway, that's the theory lesson over. Well done on getting to the end of chapter 1. And with that all said, it's time to get our hands dirty with some code as we dive into our first project in chapter 2 of this Backend Full Course. Alrighty, you know what they say? With the theory done, the fun may now begun. That's a good one for you. Now, it's time to dive into chapter 2, which is our first practical introduction to backend development. And at this point, we're going to quickly introduce some of the technology you will need, you probably already have it installed on your device, to complete this Backend Full Course. There's 3 particular installations you will be needing. Number 1 is a code editor. We're going to be using VS Code on my device. The link to download Visual Studio Code is available in the description down below. You can select your operating system and install it. You probably used it before if you know JavaScript, but this is obviously what the window looks like when you open it up, something a bit resemblant of this. You might have a different theme, but yes, you will need Visual Studio Code, a place to write all of the JavaScript and build out our backend infrastructure. Now for the second installation, it's going to be Node.js, where we have JavaScript. We write JavaScript as JavaScript set of instructions. We need what is known as a JavaScript runtime. A runtime interprets and executes your instructions. And the runtime we're going to be using is Node.js. We are going to install it on our device, and the link to download it is available in the description down below. You can either install it via Package Manager or pre-built installer. Once again, choose your operating system. As for the version, I'd recommend the LTS version or current version. We're going to learn how we can meddle with the versions later in this course, so at the end of the day, it's not that important. And the last installation is going to be Docker. Now, if you're unfamiliar with Docker, essentially what Docker does is it allows you to containerize your applications. Now, the reason Docker is brilliant is because the code that we write is often dependent on a particular operating system. And what Docker allows you to do is containerize your application and create a set of instructions for this container, which is just a virtual environment that can be consistently run across all sorts of systems architecture or operating systems. And it just means that you don't run into issues where one person can't run your code, you can, someone else can't, or you go to deploy your code and it's complicated because you are locked into a particular operating system. So Docker allows you to wrap your application inside of a virtual environment and then just define the set of instructions to configure the virtual environment, and you're absolutely sorted. Brilliant technology, looks brilliant on a resume, and this will come into play in Chapter 4, our final project for this full course. Once again, the link to install Docker is available in the description down below, and when you boot it up, you should end up with a window that looks a little bit like this. Now that we have all our installations done, it's time to jump into the code. So what I'm going to do to begin is open up a blank window of Visual Studio Code. So here we have my blank window open, and what we're going to do from within here is select this open button, and we're going to come to a folder. Personally, this is where I keep all of my coding projects, and in here you're going to create a new folder called Backend-Full-Course. Now I've already created my folder, so I'm just going to go ahead and select it. And once you have created or selected that folder, then you just want to select open, and that is going to open up that folder inside of Visual Studio Code, and this is where our projects in this course are going to go. Now over on the side here, we can in fact confirm that we are in the correct folder directory, because if we open up our Explorer, here it says Backend Full Course. And I already have one folder in here. It's the Chapter 1 folder, which contains a document that is just the written version of the theory lesson. So if you want to refer back to that at any point, you can find this Chapter 1 folder and download it to your project directory, or just refer to it in the GitHub repo, which is linked in the description down below. So you just want to open up the Chapter 1 directory and look for the theory.markdown file. Totally not necessary, just if you want to have it there. Now the first thing we're going to do in here is create a folder for our Chapter 2 project. So what I'm going to do is right click and create a new folder. Equally, you can use these action buttons right here. And I'm just going to create a folder called chapter_2. If I hit enter on that, that is now created, and it is within this folder that we are going to house our very first backend project. Now, when we're first getting started with a backend project using Node.js and JavaScript, there's a number of ways that we can go about configuring this project. Now, typically when you're developing backend code inside of JavaScript, we like to take advantage of what is known as the Node Package Manager ecosystem, where essentially what that is a whole lot of different packages or code libraries that we can very easily gain access to and utilize them inside of our code base to save us having to do everything from the very beginning. Super standard practice if you're developing backend applications inside of Node.js and JavaScript, and we're going to see how to do it. But essentially what it requires us to do is initialize our project as a Node npm project. Now to do that, super simple, the first thing we're going to do is open up a terminal instance inside of our Visual Studio Code. I like to use the control backtick keys to toggle a terminal instance just like that. Now if you want to know all the key shortcuts that I use inside of VS Code to speed up my coding process, there is a link to a website that explains all of them in the description down below, including the key command to toggle your terminal. You can also open up a terminal instance from the folder options just as equally. Now with this terminal instance open, the first thing we note is that we are in the Backend Full Course project directory inside of our terminal. We actually want to be inside of chapter_2. So the first command we're going to type in here is the cd or change directory command. And then we're just going to specify the folder to which we want to enter, which is the chapter_2 folder directory. And if I go ahead and hit enter on that, we can see that our folder directory inside of our terminal has now been updated to chapter 2. So we're officially inside of our folder directory, and this is where we're going to initialize our project. Now, to be able to initialize a project, the first thing we're going to have to do is ensure that we have Node installed on our device correctly. Now, there's a very easy way to check whether or not you have Node installed on your device. All you do is you type the node space -v, the -v flag, inside of your terminal and hit enter. And if you have successfully installed Node.js on your device, you should get a version popping up right here. If you receive any type of error, that means your installation is either incomplete or incorrect. So that's just one thing we need to do to confirm that Node is installed on our device. Once again, you don't have to worry about the version of Node that you have installed on your computer. We're going to learn how we can meddle with the Node version later in this course. That will become important in chapters 3 and 4. So now that we've confirmed Node is working, we should also be able to access npm-v. So you can run the npm-v command. That will ensure that you have access to Node Package Manager on your computer. And then what we can do is run the npm init command with the -y flag. Now this command is going to initialize our Node.js backend project inside of our chapter 2 folder directory. So if I go ahead and hit enter there, we can see that we get an output in our terminal. We get told that we wrote to a particular file, the package.json file, and we wrote this code to this JSON to that file. So now if we come over to what was originally an empty chapter 2 folder, we can see that we have a file inside called our package.json file. Now what this file is, it's a JSON file, so it's basically just a glorified string object. It essentially just qualifies exactly what our project is all about. It's kind of like a specs or specification file. So up here we can see we have some fields, the name of the project, the version. You can modify the version when you publish your project to production. We can give our project a description, so we could say a simple backend server. Underneath that we have a main. That's not really relevant to us. We have a scripts field. This is going to be very relevant to us. We'll see exactly how later. And then we just have some other fields that at the moment aren't really that important. But the moral of the story is that this file is going to contain all the specifications for our project. Now I'm going to go ahead and create another file inside of this folder. So I'm going to select that folder, create a new file, and this is going to be called server.javascript or .js, which is the JavaScript file extension. Now if I go ahead and click enter on that server.js, that's going to initialize that JavaScript file, and we can see in here I can open it up, type a whole lot of code. It's all sorts of JavaScript. And this is where, for this project, we're going to create our server application, our backend project. Now, when it comes to creating server-side applications or backend applications inside of Node.js, a common framework or package that is used available within the Node Package Manager ecosystem is called Express. Now, you technically don't need Express to create a JavaScript file and set it up to listen to incoming network requests and act as a server. However, it is infinitely easier using a package like Express, because Express is designed specifically for that purpose. As we can see here, it's a fast, unopinionated, minimalist web framework for Node.js. So we're going to be using that inside of this course. It's incredibly common. You'll find most big enterprise level backend applications built out of Node.js will use Express or an equivalent package to basically allow them to build these backend applications. So what we need to do now that we have a server is add this package to our project. And we can see that, in this website right here for this package, they tell us exactly how we go about doing that. And we just run this npm install express command inside of our terminal. So if I come back over to the code, specifically the terminal, what I'm going to do down here is clear everything out. And I'm now going to run npm install, which is how we install packages from the npm or Node Package Manager ecosystem. And I'm going to install the Express package. So if I hit enter on that, that's going to go ahead and download everything we need to utilize that package inside of our project. So here we can see it's added a whole lot of packages in a very short time span. And we can also see that a whole bunch of files and folders have been added to our chapter 2 project directory. Now, we obviously had the server.js, and we originally had a package.json after we initialized our Node.js project. If we come into the package.json, we can see that one thing has changed. We now have this dependencies field, and within the dependencies field, we have the Express package listed. This is super important because, once again, our specs for the project need to specify what code packages our project is dependent on. Hence, we list Express as a dependency. We also specify what version we use for our project. Once again, it's not too important if your version isn't exactly equal to mine. As long as they're approximately the same, the code should all be equivalent. Now, the other reason this dependencies field is important is because if someone else downloads your code base, they need to be able to install all of the necessary packages to run your code. Just as equally, if you were to publish this to a production environment, a live environment for the internet, when you configure that environment, it needs to know what dependencies to install to get your project up and running. Now, as for where these packages have been downloaded to, everything is within the node modules file. So if we go ahead and open that up, that's got a whole lot of files and folders in there. We will not be touching any of them. All of those packages just get thrown into the node modules file or folder, and that just sits there and we don't need to do anything about it. We can see we also have this package-lock.json. That's another complicated file that we're really just not going to be touching. It's not one that you want to meddle with. The folders and files that are important to us are specifically for now this package.json and the server.javascript. Now, to initialize a server inside of a Node.js or JavaScript file using Express, it literally only takes about 4 lines of code. So it's incredibly easy to get a server up and running. That doesn't mean that the server is complete, but it's a good start. So that's exactly what we're going to do now. So to initialize a server using Express, the first thing we need to do is define a variable called Express and set it equal to, and what we set it equal to is we require in the Express package. So essentially what this line of code does is it requires the Express package, and we assign whatever is in that pre-existing code, that package, to this variable so that we can then use it all throughout our project. So that basically imports Express into our code base right here. The next thing we need to do, now that we have access to Express, is to define our backend application. And we do that very simply by defining a variable called app and setting it equal to, and we invoke Express as a function. So that's going to create our backend application for us. And then the last step is we say app. And if you recall from our lesson, from our theory lesson, the backend is just hardware running software that is connected to the internet that listens to incoming requests to its IP address. So we have this server app, and the last thing we always do, this line goes at the very bottom of our code, is we configure it and then we tell it to listen to incoming requests. So that's what this line does. Now, when it comes to telling an app to listen, one parameter we need to provide it is known as a port, which is basically just a subdirectory within the IP address. So the IP address is the address of the device, and the port is a location within that device. And so what we're going to do in here is define a port. I'm going to use all uppercase as a variable. And I personally like to use 8383. Typically, it's a 4-digit number. Some common ones are 3000, 8000, so on and so forth. I just like 8383. Those are my lucky numbers. So now we have this port. What we can do is we can pass in the port as an argument to the listen. And we can say, all right, Mr. Server App, I now want you to listen to incoming requests to this IP address specifically at this port. Now, there's one other argument we can pass to this listen function, and that is a callback function. So in here, I'm going to create this arrow function, And once again, just a reminder, if your JavaScript needs a bit of brushing up on, there is a course linked in the description down below. But anyway, in here we have an arrow function. This is a callback function to be executed when our server is up and running. And all we're going to do in here is console.log. So we're going to log something to the console. It's going to be a template literal string. And it's just going to say server has started on. And then I'm going to use the $sign and the curly braces to inject the port variable into this template literal string. So with that all done, these are the 4 lines of code that we need to create a server that is officially listening to incoming requests over the internet. So obviously the next thing we need to do is actually run this file. Now there's a number of different ways that we could go about doing that. One is very simply to tell Node to read the server.js file and go ahead and execute that file. So if I hit enter on that, we can see that right here, I get this output. Server has started on port 8383. Absolutely brilliant. Our server is up and running. And one other thing to note is that we never finished the execution of that file. It's kind of stuck in limbo, and that will remain to be the case while our server is indefinitely listening to these incoming requests. So here it's a continued execution of this file, or basically we never ended the initial execution of this file. It's still running, it's still listening to these incoming network requests. So that's pretty neat. Congratulations, you have officially, with 4 lines of code, created a server that is technically connected to the internet, listening to these incoming requests. That is a solid backend application that doesn't actually do anything. But you know, it's a start. Now, what I'm actually going to do at this point is kill the execution of this server. And I'm going to do that using the Control and C keys. So there I typed the Control and C keys, and that killed the execution of the file, and I now have access to my terminal once again and can write some additional commands. So that's pretty cool. Now in this project, that's actually not how we're going to go about booting up our server. We're going to do everything via npm and via this package.json, basically through the specs file. Now in here, we have a field called scripts, and we're going to go ahead and add a script where the script is just a set of instructions to basically get our server up and running. Now the first thing you have to do to add a new script is give it a title or key. In this case, it's going to be called dev. And then what I do is I set it equal to a string, adding a comma to the end of that field to keep the JSON happy. And in here, I'm going to insert that command. So that's going to be node server.js. Now that's just the same command we ran earlier, and if you were just running between these two boot up instances, it wouldn't really matter which one you did, but it's good to get into the practice of doing it via the package.json and the script methodology, because occasionally these scripts, these startup commands, become a lot more intricate and complicated. So now we've gone ahead and added this simple dev script right here. I'm going to go ahead and save that package.json file. Now what we can do to boot up our server is we can tell npm to run that particular script. So all we do in here is we type npm, we say run the dev script, and that's going to execute that line of code. And we can see here it checked what the line of code to be executed was, node server.js, and it booted up our server once again to the same outcome. Now that's still actually not the way that we're going to go about booting up our server throughout this course. And the main reason for that is because if I now come in here and change something about my server, let's say I console.log, this is an extra line, and save that. What's happened? Absolutely nothing has happened. So to get that change to be reflected in the server execution, I would now have to kill my file and boot it up again. And now we can see we get that extra line. But if you're regularly making changes to your files, that's super annoying to have to restart your server every single time. So what we're going to do is once more kill our server execution, our server application, using the Control-C key, and we're going to install one more package called npm install nodemon, so Nodemon. Now, NodeMon is going to be what's known as a developer dependency. And what that means is that it's not something you would use in production. It's specifically for development, because that's when we're going to be making a mass amount of modifications to our file and needing it to regularly update. So we're going to install it slightly differently. We're going to write npm install and then use a --save--dev flag and then name the NodeMon package. Now when I hit enter on this command, it's going to go ahead and install that package. All that code will be added to the node modules. But now when I come into the package.json, we can see that it actually hasn't added it to the dependencies field, but it has added it to the developer dependencies field. And that means that when we publish this code to production, it's not going to worry about installing dependencies that are specifically for quality of life improvements when you're developing the code. Now what we can do with NodeMon installed as a developer dependency is slightly adjust this script to instead be NodeMon. Instead of just node, it's now NodeMon server.javascript. And then we're going to go ahead and save the package.json file. With all of that done, we can now run npm run the developer script. If I hit enter on that, we can see once again we've got this as an extra line running, consoling out. We can see that our server has started. We can see that it's a continued execution. However, now when I come in here and remove this line and save this file, we can see that our server was automatically restarted to reflect the changes in the code. And that is going to be infinitely more convenient than constantly restarting our server every time we make adjustments to it. So that's absolutely brilliant. Now we have defined the code to initialize our server, and we've got it set up to be really easy to work on, modify, update, and add all the functionality we need to it to complete this project. So now that I've created a server that is listening for incoming requests across a network requests, does that mean I have a functional server? Well, let's go ahead and find out. Now, earlier in the theory lesson, I mentioned that one way we interact with these servers is via their address. So what that means is that right now, this server that is connected to the internet has an address that we can send network requests to. So from a technical standpoint, the address of this server connected to the network is localhost. It's http://localhost 8383. This is the address or URL that is mapped to the IP address that locates this server in the network. Now, where this instance is the URL, so if we actually just specify the address, let's call this one the URL. Now, I said earlier that every URL is mapped to an IP address, so the IP equivalent is this series of numbers right here. So if we were to go to a browser and enter this URL or this IP address, both of them locate our server across the local network, and that would be valid. And I think technically that would actually have to be 8383 because we have to specify the port within the address of the device. So why don't we actually go ahead and try this? And once again, if you want to copy these are available inside of the GitHub code, inside of chapter 2, the server.js. So if I come over to my browser, I should technically be able to copy this URL, paste it in here, and hit enter. But now we can see we actually get an error response that says cannot get. And what we can do from within a browser is we can right click on this browser, click inspect, and that's going to open up the Chrome developer tools, and we can come over to the network tab. Now within the network tab, that's going to let us see, and keep in mind that this is the client side. All of this is server side, all of this is client side, even though technically they're on the same device for the sake of development. The client, when we hit enter on that URL, sends out a network request across the local network for development that reaches this backend code, and then it consequently responds. And so that's something that we can track our browser actually doing from within this network tab. So if I refresh this whole process and hit enter on this URL, we can see right here that a network request was emitted from our client, from our browser. If we take a look at the headers, which are basically the properties or parameters that specify the intent of the network request, here we can see we have the request URL, which is the address. We can see that we have a method, which is the verb that describes the action of the request. In this case, it's typically to get a website. When you enter a URL into the browser, it's typically to get access to a website. And so this network request has gone out into the local network. It's found our server, has told the server that it wants a website, but it's received a response that says 404. That's a status code. It describes what is actually happening in the response. But at the end of the day, the summary is not found, cannot get that website. So the question becomes, what's actually happening here? Now, one of the keys or answers is this little slash right here, in addition to the get, to be fair. And essentially what we have to do is we actually need to configure our server to interpret these incoming requests. Now, some of the things we need to set it up to interpret are known as the HTTP verbs and the routes or paths. Now, in this case right up here, this slash is known as the path, and this get is the HTTP verb. As far as a URL goes, if I add a slash here, that slash is for the home path. If I were to have a dashboard, that would be to the dashboard path. If I were to have an auth path, that's obviously an auth path, and then we could have slash auth slash dashboard, so on and so forth. These are all of the routes or paths, and they are part of the request URL. Now that is like, once again, in addition to how the port works, that's a further subdirectory to which we need to navigate these incoming requests. And then we can define actions at each of these endpoints. These can be referred to as endpoints. There's specific subregions within our server that is listening to this incoming or all of these incoming network requests, where we can direct the code to a specific endpoint and execute a body of logic to respond appropriately. Now that's a whole lot of words right there. You'll see how it works very shortly. But the other thing we have to throw into the mix here is that obviously we have these routes now, where once again, by default, the route is the slash, so we can see that gives us the exact same response. The second thing we need to do is configure our routes to listen to these or interpret these specific verbs, which help us further understand the intention of the network request. Now, just before we do that, one other thing I want to point out is that if we use this IP instead of the URL, that's going to give us the exact same response, and that is because the URL is then converted to an IP address, so we can just skip that step and use the IP address directly. But obviously that's going to be a lot harder for a human to remember. Now I've kind of said it here, the next step is to add in the HTTP verbs and routes. But how does that work? Well, essentially what we need to do is configure our app for these verbs and these routes. Now, this is kind of like, anticipating what a user is going to do. So for example, I could write app and I could assume that they want to get information. When a user comes to my website, I can assume that they want to get something. That's a pretty standard response. And so what we do is we invoke this get method and we configure it. Now, the first argument that gets passed into the get method is the route. So in here, what I'm going to do is use the slash route, because up here we're saying we cannot get that home default slash route. Well, now I'm going to configure our server to handle incoming get requests to this home route. And then what we do is we define some logic to run when we get these incoming network requests that want to get information at the home route. And the way that we do that is by providing a second argument to this get method that is an arrow function that has two arguments, a request and a response argument. Now that I have access to the request and the response, in here I can define some code to be executed when our server receives incoming requests to the /home route that are get requests. If we look at this network request right here, we can see that the method is get. So just to summarize that, the method informs the nature of request, and the route is a further subdirectory. Basically, we direct the request to the body of code to respond appropriately, and these locations or routes are called endpoints. So technically, this is endpoint number 1, and it's at the /route. Once again, this might be a little bit confusing initially, but as we do it more and more, it will become more apparent and obvious to you. So now we have some code in here for the GET request, the incoming GET request, which are the HTTP verbs to describe the intent of the request. A verb is an action word, GET is to get information. And these requests are directed to the /endpoint within our server. So in here, what I'm going to do is have a console.log that says, yay, I hit an endpoint. And I'm just going to go ahead and save that. Now that NodeMon has restarted our server, what I'm then going to do is go ahead and hit enter on this network request again. And we can see this time, we actually got a different response. We didn't get an error immediately, we will soon, but we actually got a different response, and we can see that that website is still loading. But if we come over to our console, that was from earlier, that's not from this one, we have absolutely nothing inside of our client-side console. But if we come over to our server-side code, we can see that we actually executed this console.log, which means that that incoming network request was heard by our server, and this callback function was executed. So in here, we can now define a whole lot of code to handle that incoming request. Now, one thing I just want to point out once again is that the app needs to be configured first, and then we tell it to listen second. So this line of code always needs to be down the very bottom. So to summarize what I just said, we said that this endpoint has officially received this request. And the way that we understand exactly what its intention is via this request argument right here. And the way that we respond is using this response argument. So in here, what I can do is I can console.log the request.method. And the method is the HTTP verb, so that's pretty straightforward. That could be kind of fun. And to respond, what we're going to do is we're going to call res, and we're going to learn our very first response type. You know, some responses send back HTML code, some send JSON data, some send all sorts of stuff, some send straight up strings. We're going to send a status code of 200. Now I'll explain what that means in just a second. So if we go ahead and save that, our code restarts. And now if I refresh this page, we no longer get an error here. If I look at the network, we can see that we get a 300 response right here. We can see that we do in fact get something back, and we get this little text element right here that just says OK. And that is brilliant. We officially removed all the errors from our application, and we now have a full stack interaction where we can send out network requests from the client. They can reach our server that is listening to these incoming network requests at its IP address specified right here. It can interpret them by interpreting the intention or verb of the incoming request, and also the route or path or endpoint destination, which is in this case is the home or /route. Now, as for what the status codes mean, whenever you have a network request, we have a bunch of codes, response codes or status codes, that basically are a shorthand determination of the outcome of that initial request. So any response code that is 200 level, so 200 to 299, basically, suggests that it was a successful request. In this case, we got back an OK, Roger, cool, absolutely sweet. 300 level responses are a bit more uncommon, just like 100. The most common are 200, so you could have 200, 201, 203, 202. Then there's 400 level responses. So we saw earlier that we had a 404. That means not found. And typically what that means is that there was an error in communication. So anything 400 level is kind of an error in communication. So 403 means that it's a forbidden request, which means that you're not authorized to do that. 500 level requests mean that there was an error on the server side. So we received your request and something went wrong. So there's a whole lot of different status codes that we can associate with the response. Now this line right here, doing something with this res is absolutely critical to define how your server is meant to respond when an incoming request hits that particular endpoint or this body of code. So for the minute, what I'm going to do is just send back a 201 status in this case. I'm going to go ahead and hit enter on that, and we can see that gave us back a created response, and that's because the 201 status code says that you have created something. We can see that information right here in that network request. We can see that the headers, which specify the intent of the network request, were to get some information at this IP address right here. We can preview it, doesn't look like anything, and we can see the response, which is a created status. Now, what happens if I type in /dashboard? Well, we get a very similar error to before, where we cannot get the /dashboard route. There's nothing there. And if we look at this error code, we can see that now it's to the /dashboard URL or route within our entire URL, and we got back a 404 status code, which means that we can't find anything. So the way that we would have to go about configuring our server to receive incoming requests at this URL is by telling our app to listen to these GET requests at this particular route. So we can do that very easily. Just underneath right here, we can say app.get. We can pass in the /dashboard route, and then we can pass in this callback function, receiving the request and response arguments. And in here I can say console.log. Ooh, now I hit the /dashboard endpoint. And what I can also do is res.send. I'm not sending a status. In this case, I'm just going to send the string hi. Now, just before I save that, one other thing I want to point out is that here we consoled get, and that's the request.method. So that's an example of how we can interpret these requests. We're listening for these incoming requests. We can see what the method is. We can do all sorts of stuff to understand what exactly is contained within this incoming request. Anyway, we've now defined a second endpoint. It's a get endpoint at the /dashboard route, and it's going to console some different text, and it's just ultimately going to send back a response, which is a string that says hi. So if I go ahead and save that, our code, our server restarts, and if I now re-hit enter on that URL, we can see that we get back the response hi. So that is super cool. We can see that the default status code of this response was 200. So in this case, we didn't specify a status, but it just defaulted to 200 because it was a successful request. All of the information is okay. This is the URL that we sent it out to. The headers are basically the properties or parameters of the network request. We got back a 200 level response. There's loads of information in here, and we can preview the response that says hi, and we can look at it and it's just a string. The other cool thing you can do is you can typically see exactly how long it took. So up here, I believe that would be the length of time taken to complete that response, which is about 40 milliseconds, which is very fast. And just like that, we have officially defined two endpoints where both of these endpoints use the get HTTP verb, and we've seen how we can navigate or direct these incoming requests to certain endpoints or routes, and consequently how we can respond back to them using the ExpressJS framework. So that's super cool. And now the next steps are to tidy up the code that we have here so that it actually resembles a more traditional web server. So one of the weird things that's happening right here is we're obviously sending out these network requests where the default method when you send out a network request from the client via the URL bar is of method get. Now, one thing I wanted to clarify up here is that HTTP verbs are the same thing as the method, which is just once again the action, and together these create the endpoint, which we can think of as literally the end destination of that network request before it's handled and consequently responded. Now, these are both, technically speaking, how we actually create the endpoints within our server-side application, within our Node.js backend. And so we create loads of different endpoints to handle all sorts of different incoming network requests. So this is obviously a get endpoint to this particular route, so on and so forth. Now, obviously, in both of these cases, in this one I send back a status code, and that's cool and all. In this one I send back a string, but that still doesn't explain how we end up with a website on our screen. When I come to a web URL, in this case it's localhost 8383, you can imagine that's google.com, this is just for local development. I hit enter, I send out a network request across the network to the IP address that is associated with my backend server, which is this one right here. Where's the website? Well, excellent question. So what we're going to do now is learn how we can convert these to actually send back a website. Now, obviously, a website is HTML code, and so in future we're going to learn how we can send back a whole HTML file. But if we just really want to simplify that whole process, at its very core, all we're doing is we're responding, and we send back, and I'm going to create a string, and in here I'm going to create an h1 tag, which is HTML. We need the corresponding closing tag, and this is literally just going to say this is actually our website, in brackets HTML code. So now what I'm going to do is save that. Our server is going to restart, and now I'm going to refresh the page, and this time we actually got back HTML code. If I can just move this down somehow. Where's the little scrolly bar? It's gone from the world, or so it would seem. Come on, you can do it. If I can just inspect this properly, elements, everything's up there. But the moral of the story is that there's going to be HTML code in there, but I can't get to it. Silly, silly, silly. Anyway, the point is that this is HTML code. I could send back after that an input. Just like that. That's the HTML code for an input. And now when I refresh the page, we actually get an input sent back. And this is how you end up with a website on your screen. We go to this URL right here. It's a get URL. It's to get a website. And when it hits this endpoint, when our server receives that incoming request, we recognize that it's a get request. Its its destination is this particular route. It hits this endpoint. So we know that the user wants a website, so we can literally just send them back a website. Now, that's obviously one manner of communication. One type of network request is to get websites. And this is where we need to really tidy up our server, because, for example, this dashboard route right here, if someone's going to the dashboard route, you can imagine they want the home page for the dashboard. They don't want some silly response that says hi. But sometimes we literally need to send out responses that say hi and don't load websites. So what I like to do inside of my endpoints is I like to have some, website endpoints, just like this. And then I like to have a second type of websites, which is more for like API endpoints. Now, the difference between the two of them is that website endpoints are specifically for sending back HTML. So these endpoints are for sending back HTML, and they typically come when a user enters a URL in a browser, like we have been. API endpoints are more like what happens when you type in your username and password and you hit submit. That sends out the same network request, it hits the backend, we locate it to an API endpoint, except these ones obviously don't send back a website. So we kind of, that's where the magic happens behind the scenes, and we do something different with these. And the point I'm trying to make with all of this is that just here, these two endpoints, I'm going to move them into this first division of endpoint, which is the website endpoint. So I might actually just label this. This is going to be type 1, website endpoints, and then these are going to be type 2. We'll call these non-visual API endpoints. And so now what I'm going to do is I'm going to change this first one, the response, so that it's, let's just call it home page. So that's what it sends back as a home page. You can just imagine this as a whole lot more HTML code that is literally the home page for our website. And then in this one right here, I'm going to send back the exact same thing except for a dashboard. So in this case, instead of it being home page, it's going to be dashboard. If I can spell that correctly. So here we're going to send back the dashboard. Now when I refresh the page, this one's the home page, which is what we'd expect. We get the website back. Now if I go to the dashboard link, we locate the dashboard. That's absolutely wicked. For these ones down here, I'm going to define another endpoint. This is going to be a get endpoint, except this one's going to be /API/data. Now in this case, we don't have any data, but what if our website, was, for example, a job board, and our server has all of these job listings that a user needs to get access to? Well, the client is going to send out that network request to the server and request all of that data, all of those job listings. And because we're not sending back, a website or anything, it's not really going to be a URL that gets entered inside of a browser. I like to start them off with this /API endpoint because it just basically signifies that this one isn't sending back HTML. It's more of a non-visual behind the scenes network communication request. It's still exactly the same, request, response, arrow function. In here we can console.log. This one was for data. Except now what I would do is I would send back, I would res.send my data. Now for the minute I actually don't have any data, so what I'm going to do is just up here, I'm going to define some data. I'm going to say let data equal an object, and that object is going to have a name that is equal to James. So this is our object, this is our data. So now we have a backend server that serves up some HTML code when people type in those URLs. What we now also have is a means for letting someone get data. Now the question at this point becomes, we've established that this endpoint here, it's a get request. They want to get data, but it's not really a website that they're getting, so it doesn't make sense that they would type it into a URL or a nav bar. Is to this particular route, how do we go about testing this? What do we actually do? And this is where a tool known as a client emulator becomes extremely helpful. So what we're going to do is we're going to come over to the extensions tab right here, and we're going to look up an extension called the REST client. Now it's the top one right up here. It's by Hua Chao Mao. It's got over 5 million installations. It's absolutely brilliant. And you'll just want to hit install on that extension. And once we have that extension installed, within our chapter 2 folder, we're going to create a new file. And this one is going to be called test.rest, or also .client is valid as well, but we're going with .rest. .rest is the extension that we'll need. Now what this file allows us to do is emulate the process of sending out a network request. So it basically emulates a browser or a user. For example, in here, we separate all the template network requests we want to send out using the £. And the first one, I can actually give this one a title. This is going to be to test get homepage website. And now to actually write the code in here, what I would do is I'd specify it's a GET request, and I'm sending it to http://localhost 8383, which is the URL. Now we can see that if I save that, we get this tiny little send request button up here. And if I click on that, it emulates that whole functionality of us typing in the URL here. Except instead of displaying the HTML code as a website in the browser, we can inspect literally what the response is, which is the HTML code. We can see that it was a 200 level response. We can see it was powered by Express. We can see that we get back HTML code, and that was a successful request. Now I can do the exact same for test get /dashboard website. And then here I'll just type get http://localhost 8383. We give the address, then we give the route, which is the dashboard. And we have defined this endpoint, so that's all good. I hit send, it sends that request. We can see it took 7 milliseconds down here. And we now get back that HTML code for the dashboard. And obviously these are our website endpoints that we're testing here, but I can also do it for a data endpoint. So what I could do is I could use the get method, the get verb, and go http://localhost 8383/API/data, which is our most recent endpoint that we've added. And now let's say I wanted to test that. A user comes onto our website, we need to ensure that they can fetch all of the job postings for our job board. So we run this network request, it hits that endpoint, and now we can see we get back JSON data. And we also console, this one was for data. And so this is a client emulator. It sent out a network request from this client. It hit our server directed it to this specific endpoint. It interpreted the method of the request, which is to get information. It located it or navigated it to this particular route. We ran this console and we responded with the data. So that's super cool. It's a different kind of endpoint. It doesn't really show up a website. It's not something you would typically type in a URL, even though technically you could. In here I can go API/data, and it will show me the data, which is JSON, but that is not a website. So that's just another endpoint that we have officially configured. So now that we have these three endpoints, it's time we start looking at some of the different HTTP verbs or methods. Now, at the end of the day, most of these methods all come under the umbrella term of CRUD actions. So if we take a look at the term CRUD, I'm actually going to write it in here. CRUD stands for create, read, update, and delete. Now, if we think about, these are the four actions that basically control all of data modification. The read is get. That's obviously associated with a get request. So to read information is to get information. If we want to create, the HTTP verb that's associated with is called post. You post a parcel to someone else, and it creates that package in their hand. If we wanted to update information, we use a put, because we put something in the place of something that was already existing. We create that place for it with a post request, and then we put something there with a put request. And a delete request, or the delete functionality, is literally associated with the delete method. So in here, what this is actually doing is we have the method and the CRUD action. So the method is on the left and the CRUD action is on the right, and I actually got that around the wrong way. It's the CRUD action on the left and the method on the right. So that's pretty cool. Now what we're going to do is really take this application to the next level by literally creating something that is going to display our data. So in here, what I'm going to do is for our home page, which we have right here, I'm going to turn this into a template literal string, and that's going to allow us to inject some data. So this is our template literal string. I'm going to enter it onto a new line, which we can do with template literal strings. And we know that HTML code needs a body. That's where all of the visible part of the website, the visible HTML code goes within the body tags, within the body opening and closing tags. And in here, what I'm going to do is create a paragraph opening and closing tag. And within that, I'm going to use the $ curly braces, and I'm going to JSON.stringify our data. So this is going to inject our data into this template literal string and send it over as the HTML code. So now if I refresh this page and hit enter, we can see now we get back the JSON code for our data. And I'm going to actually throw an h1 tag above that, and that's just going to be called data. And I'm actually going to give this a style tag, the body a style tag, and that's going to be equal to background pink, color blue. That's going to look shocking. So now if I save and refresh that, we can see we have a website and we have our data, so that's kind of fun. We added the style tags, we sent back the HTML code, someone loaded the website, and that's how every website you ever go to on the internet actually works. So that's super cool. Now, let's get creative. How do we actually add, modify data, all of that kind of stuff? Well, that's where we get to these funky API endpoints, and that's where we're also going to use our client emulator. So what I'm going to do in here is I'm going to create an endpoint that allows someone to add data. So in this case, I'm going to use the new method we talked about here, which is to post. So I'm going to expect that someone's going to post some data, and I'm going to ensure that it is sent to the API/data route, because these are all the routes that are responsible for handling that data. And in here, once again, I'm going to define the function to handle the incoming request when it hits this endpoint. So that's a request and a response as arguments. And in here, what I'm going to do, if someone is actually sending information instead of just asking for information, I actually need to take a second to investigate what they're actually sending me, which we haven't had to do before. Now, fortunately, that's very easy to do with Express. With Express, typically when people send information, there's a number of ways they can send information, but most commonly it's as JSON. It's formatted as JSON. And so what I can do here is define a variable called const new data or new entry and set that equal to, I can access the request, which is the incoming request, and I can look for the body of the request. Now the body of the request is literally the data associated with that request. And typically when you have the create and post methods and the update and put and occasionally the deletes, you can typically expect there to be a body associated with that request instead of just a request for information, which would be more related to the read or get requests. So because in this case, someone wants to actually create a user, let's say for example, when they click a sign up button, what would happen is the user clicks the sign up button after entering their credentials, and their browser is wired up to send out a network request to the server to handle that action. And that's what this endpoint is for. So let's actually take a second to go ahead and program that from within our client emulator. So here we have our get endpoint. We need a new one. we're going to use the triple pound, and we're going to say data endpoint for adding a user. Now in this case, as we saw inside of the server, that is a post request because we're creating a user. So we specify the verb, and now we still need the URL, including the route where that request gets, directed to when it reaches our server. So this obviously locates the server with the domain and the IP address, and then this route locates specifically the endpoint within the server that contains the logic needed to handle this request. Now, since we're actually posting information, we need to define that information, and so what we're going to do is create a JSON object just here. You need to have an empty space above this object for formatting, and I'm going to have a name, and that is going to be Gilgamesh, because why not? Let's support Gilgamesh. So that is the data formatted as JSON that we want to send. Now when we're sending data, the one last thing we want to do is configure a parameter of the network request, which is known as the content type. And we just set that to application/JSON. And that means when our server receives this request from our client emulator, it knows that it's looking for JSON, and it can consequently pass that body and interpret that JSON and gain access to this value. So now we have a post endpoint where we can access the body. We currently haven't defined how we want to respond to it, but let's just go ahead and send this request from our client emulator. And you have to remember that this would be equivalent to, if they had a website where it's like submit a new account, add a user, add a to-do, they're clicking the button, and this is what happens. So we send out that request, and we see that it's just waiting indefinitely. Now there's a few things to note. First up, that we're not getting a response, and that's because we haven't basically told this endpoint how to respond when it receives this request. So that's what we're going to do next. So I just went ahead and canceled that request, and we got nothing back. Now, to respond, this is where we would send the status code of 201, which, if you recall, was associated with the created, outcome. A user was created or added. So that would be a perfect response to that. So let's go ahead and send that request, and this time we get back a 201, which says that we have created a new user. So that's pretty cool. Now what we're also going to do before we respond is we're actually going to console.log this new entry, restart that, and I'm going to go ahead and send this request again, and we can see that even though we tried to console.log the body of the request.body, we get undefined. And that's because up here where we configure our server, there's one last thing we have to do. So I'm going to create a section in here called middleware, and we just have to tell our app to use express.json, and we invoke the JSON method. Now middleware is part of configuring your server, and basically it's configuration that you slam in between the incoming request and interpreting that request. So a request hits your server. This is like a protective layer on the, like a middle in between these interactions. So it's just before we actually hit these endpoints. And this line just basically configures our server to expect JSON data as an incoming request. So now that we've added this line right here, we're telling our app that it needs to use this express.json, expect to receive this JSON data. Now when I send that request, we can see that we actually logged out the new data, and consequently our server responded to the client emulator, and we got a successful response code. Now the one last thing I want to do here is actually add the data. So what I'm going to do is reformat it, and I'm just going to create a users field, and it's going to be an array, and that's just going to have the entry James. And to be fair, what I could do is get rid of a lot of this and just literally make it an array with the name James. So now when I refresh the page, we can see we get the array back James. That's the data rendered onto the screen. Now what I want to do is add a user. So we come down to this particular endpoint where we're handling this data. It's an API endpoint. It's not for rendering a website. And we're just going to say data.push, and we're going to push the new user. Here we can see that we have to access the name parameter within the new entry. So we push the new entry.name field because that's what we want to gain access to. That's an object. The request.body is an object. And we access the name key within that object. We push it to our data array, and then we confirm that we have created that new entry. So now when I save that, if I refresh the page, we get our singular entry inside of this array rendered as our website. And now we come over to our client emulator. We emulate the process of adding a new user by sending this request. Gilgamesh has been added. We have confirmed that we have added Gilgamesh. And now when I refresh this page, we can see that Gilgamesh has been added to this list. So that's absolutely wicked. We can see now that, we're really developing a full stack interaction where we have a client where we can actually visually see all of these back-end interactions that are just going on by telling our server to listen to these incoming requests and defining endpoints that handle all sorts of different, behaviors, expectations, and intentions of these requests. Now, a big server might have 100 different endpoints, all for different things. But at its very core, all you're doing is creating different destinations where each route and each verb together create the endpoint, where each endpoint has, a specific utility. So that's pretty cool. If we just wanted to take this one last step, we could say app.delete. We specify the route, which is /API/endpoint, and we define the arrow function to be executed when we receive an incoming request to this endpoint. We give it the request and the response as arguments, and in here, what we do is we just say data.pop. We're going to pop an entry off the end of that element. We could also throw in a console.log just saying we deleted. I can't remember if pop is off the end. I think it's off the end. So we're going to say we deleted the element off the end of the array. And then we just res.send the status code of 203, for example. I'm sure there's one that's associated with a successful delete, but I'm not sure what it is in this moment. So what we could do now is emulate that request. I could literally just copy and paste this code right here. Actually, I'm not even going to do that. I'm just going to create a new one. So I'm going to use the £" and say delete endpoint. And that's going to be a delete request to the http:/localhost/API/data. And we have to throw the port in here. So that's 8383. And then very simply, I can go ahead and execute this request. In this case, this request does not need to contain any data because it's not specific to an entry. It just literally gets rid of the entry off the end of the array. Run that request. Oh, and we got a 404, which means that that cannot be found. And that's because I specified the route incorrectly. So here you can see that we are looking for a /data, whereas I've configured it for /endpoint because I'm a muppet. So let's now change that to API/data, save that file, re-execute that request, and we get back a 203, which is definitely the wrong response code for this action. But we have confirmed on our server side that we did in fact hit that endpoint. And now if I refresh the page, we actually got rid of both entries. Let's go ahead and restart this once more. That's going to refresh everything. So now we have James. Then we're going to add an entry, send that request. That's a user created. Now we have a new user. And then we pop a value off the end of data. So let's go emulate that behavior. A user clicks delete in a website. It's the same thing. We're just emulating it. We delete an entry and then we refresh the page and now it's worked appropriately. So now we only have one entry on the end of our array. And just like that, you can really start to see our backend application coming along. Now, the one last thing I want to do in here to really just make this feel a little bit more like a website is throw in some anchor tags that have an href. This anchor tag is going to have an href to the /dashboard route, and that's going to have the text dashboard, and then we have to close that anchor tag. And then within the dashboard, I want to do the exact same thing. So this is going to have the h1. We have to put that inside of a body tag. So I'm going to change that from a quote to a template literal string. Throw the dashboard down on a new line. Put it within the body tag. So let's create the opening and closing body tag. Enter that onto a new line. Just do some text formatting really quickly. Throw that up there. And then throw in an anchor tag just here that takes a user back to the home page. And that's just going to say home. And just with these extra lines of code, so on the home page, I've added a link to the dashboard page. And on the dashboard page, I've added a link home. If I save that and refresh this page, now we get that link. I can click it. It routes us to the dashboard page. We render that HTML code, and that's going to take us home. So that is really cool. And you could absolutely take this to the moon. For example, I could add a button in here where the button actually adds a new user, and instead of having to emulate that functionality, that could actually be done within that HTML code. I could also throw in a script in here. I can throw in a script, close the script consequently, and that's going to say console.log, this is my script. And now, let's say up here, I throw in a console.log, user requested the home page website. Now if I save this backend server and refresh the page, we can see that on the backend, we received an incoming request to this endpoint where a user is requesting the homepage website. And we can see that we responded with the HTML code, which I just cannot find where. What if I close that? There it is. There's the HTML code. And then in the console, we actually executed that script, which is so cool because that was just sent back as text. But our browser interpreted the HTML, it executed the script, and Bob's your uncle, which is absolutely wicked. Now, the one last thing I want to do just to demonstrate a small concept before we jump into the next project, which actually looks reasonable. Obviously, this is a whole hodgepodge of stuff that doesn't look very attractive, but it demonstrates a lot of important concepts, is I just want to show you an extra feature that we can kind of amend to this response right here. And essentially what we can do is we can throw in a custom status code in front of the .send, and in here, we can specify the status code that we want. So if I did like a 500 or 599, that wouldn't make any sense. But now if I come back to that GET request for that endpoint and send that, we can see that we've also specified that status code in addition to getting back the data. And then just from within here, I can add a new user, I can re-request the data, and the data has been updated. And it's super cool because this little object right here has basically been a database for us. It's obviously a very simplified version of what you'd typically find in a production level environment, but for all intents and purposes, this has been a great little database that's storing users. We can access new users, and all of this can just be scaled to the moon based off the same core concepts. So anyway, that's it for chapter 2. This is our very introductory project, just to once again demonstrate how we can actually build a functional server and do some of the core things that we talked about inside of our theory lesson. It obviously doesn't look great, but that's what chapter 3 and chapter 4 are all about. They are absolutely brilliant projects. They're super exciting, and it's time that we absolutely dive into them. Alright, we just wrapped up project number 1 in chapter 2 of this Backend Full Course. It is now time for us to jump into the second project, which is chapter 3 of this Backend Full Course. Now this is a really cool project. We're going to be using NodeJS, as we did in the first example, to develop our web server, we're also going to learn how we can take advantage of what are currently known as experimental features within Node. One specifically is the SQLite database. Now, if you're unfamiliar with SQLite, basically it's just a very lightweight SQL database that is very popular, very commonplace, and very easy to get up and running with. And it's now built into the latest versions of Node, which we are going to unlock by utilizing the most recent experimental versions of Node via something known as Node Version Manager. Now, the backend application itself that we'll be building in this course is going to take a lot of the beginner concepts we learned in the first project in Chapter 2 and really just extend upon them by ultimately just building out a more comprehensive backend application. We're also going to learn how we can tidy up our project directory, really develop a project directory that is going to set us up for success as our projects become more complex. So it should be loads of fun, and the first thing on our list is to upgrade our version of Node. Now, when you download Node, you probably selected a version to download, and we can check what that version is by typing in the node-v command in our terminal. Now, this is just the exact same terminal we were using inside of Chapter 2 in our last project, and we can see that the Node version I'm using in here is version 20.10.0. But unfortunately, that Node version will not let us take advantage of some of the experimental features within Node that are available within the more recent versions of Node.js. Now, one of the things to note about experimental features is that depending on when you watch this tutorial, they might actually just be built into your current version, but essentially Node Version Manager is going to set the minimum version we're going to need to use these tools. If these features are available in the standard Node.js version, then you won't have to add any of the experimental flags, but we'll see what that's all about shortly. But yeah, should be absolutely loads of fun. Now, to kick off this process, the first thing we're going to do is get NVM Node Version Manager up and running on our device. Now, to do so, what I've done is I've linked Node Version Manager in the description down below, and this tells you exactly how to configure it. It might look a little bit overwhelming, but at its very core, all you have to do is come down to the installing and updating section, which we can see right here. Here's the install and update. And when you see this curl command, you just need to copy it and paste it into a terminal instance. For example, the one that we have open right here. So I could literally paste that command in, and that should theoretically install Node Version Manager on our device. Once it's installed, you can check that it's installed using the nvm-v command. So just in here, if I type in nvm-v, that will tell me what version of Node Version Manager is installed on our device. And if that command's not working for you, then there's been an issue in your installation. And all of that should be covered in this guide, how to basically get it up and running. Once again, this is linked in the description down below. And if you have any challenges or the documentation isn't very clear, you're welcome to once again post them as an issue on the GitHub repo for this Backend Full Course, which is also linked in the description down below. And either myself or someone else can help you overcome that hurdle. Lastly, ChatGPT can actually be pretty good at helping you get these installations up and running as well. But ultimately, it should just be copy and paste in this one line, and then you should be able to just type the nvm-v command, and that should all be good to go. Now, once NVM is installed on your device, it's so incredibly easy to use. Here are some examples of the commands. Basically, all you have to do is type nvm install or nvm use that particular Node version. So in the case of our project, the Node version we're wanting to use is, I believe it's 22, but once again, you can use 22 or later. So what we're going to do here is we're going to type nvm install, and then we're just going to type in the version that we want to install, which is going to be 22. Once again, if you have a version that is more recent, which would result in it being a higher number, then you really don't have to worry about this part. This is just if we have an older version, or if you're watching this tutorial at the time of release. So if we hit install, that's going to go ahead and download the version of Node that we will need for this tutorial, essentially to take advantage of some of the more experimental features. So now that that is installed on our computer, we can just type nvm use22, and that's going to set us up to use that version of Node. Now, the next thing we have to do, obviously we can close chapter 2, and we're going to create a new folder, which is just going to be chapter_3. It's our chapter 3 project. Now in here, what we're going to do is absolutely nothing, because it's all going to begin within our terminal. I'm just going to type the clear command that's going to clear out the terminal. Currently, we are in the chapter 2 directory from the previous project. We need to change that. So first, what we need to do is go up a directory level. So from the chapter 2 directory to the backend full course level. And we can do that by typing the change directory or cd command, and then using the double period. That's going to jump us up a level. So now you can see we're within the backend full course directory. And from within here, we can change directory into the chapter 3 folder. And now we can go ahead and initialize our Node backend project. Now, if you remember from chapter 2, the way that we did that is by typing npm init and then the -y flag. And if we hit enter on that command, that once again creates this magical package.json file, which is the specs file for our project. So if I click on that, once again, we have a pretty rudimentary package.json file, and that's how we initialize a backend project using Node.js that allows us to leverage the npm Node Package Manager ecosystem, as we learned a little bit about in chapter 2. So now that we have this package.json file, the next thing we're going to do is actually set up our folder directories and just finish the configuration of our project so that we can then get our hands dirty with all of the code. Now, the first thing I'm going to do is within the chapter 3 folder directory, I'm going to create a file called server.javascript.js, the JavaScript file extension, and hit enter on that just like we did in chapter 2, very similar. And now that we have these two files, we can go ahead and set up some folder directories that are going to be used for their own sub-files, which is just going to help keep our code a whole lot cleaner than the example in chapter 2. So the folders we're going to need for this project, number 1 is called middleware. Now, if you remember, inside of chapter 2, we only had a very brief look at middleware right here. Middleware exists in a lot of different shapes and forms. We're going to have some middleware in this chapter 3 project that is all about authenticating a user. So that's going to be super cool. So we need a folder where inside that folder we can keep the files that maintain that code. Now, the second folder we're going to need inside of chapter 3 is called routes. Now, obviously, once again, in chapter 2, we had all of our routes set up inside this file, but you can see how it's already getting kind of long, and that's not really ideal if you want to have, a best practice implementation of a server-side application. So in this case, what we're going to do is we're going to move all of our logic that sets up how all the different endpoints work into this folder called routes. Now, after that, we need another file, and this one is going to be a new file in the chapter 3 directory that's called db.js. Now, this file is going to have all of the logic for the database, which is going to be SQLite, which is just a SQL database where SQL stands for Structured Query Language, and it has to be the most popular type of database used globally. There's a lot of different examples of SQL databases. In this case, we're using SQLite. Another common one is MySQL, and then there's also PostgreSQL, which we'll be using in chapter 4. That's going to be loads of fun. But essentially, this db.javascript file is where we're going to have all the code to configure our extra special database. And then we're going to need another folder. This folder is going to be called public. We'll learn all about what the public folder is for very shortly. And then last but not least, we're going to need 2 more files One is going to be another REST file, which is used for emulating the browser. So that's going to be called todoapp.rest, just like that. We'll create that file. And then lucky last is going to be one called .env. Now, .env files are for environment variables. And if you're unfamiliar with what an environment variable is, it's essentially just a storage of keys and values. The key is the lookup term, and the value is potentially a secret string of characters that needs to be referenced for the configuration of our project. So any top secret information is going to be thrown in this .env file, and that way we can avoid uploading it, for example, to GitHub. It can stay local on our device, and that means we don't end up in a situation where we accidentally share all of our secret passwords with the world. Now, we'll learn more about how the .env file works shortly, but first we're just going to finish up with the configuration of the files for this chapter. Another folder that we need to create is going to be called source. Now, SRC stands for source, and I actually made a little oopsie here. All of this code that we have created so far, with exception to the .env file and the todoapp.rest, needs to go inside of the source code. So our server.js is going to go into the source. I'm going to drag that in there. The database.js goes into the source, and then the middleware folder goes into the source, and so does the routes folder. So if we close the source directory, we should only have the package.json, the .env, and the REST file, in addition to the public folder as direct children of the chapter 3 directory. Within the source folder, we have this middleware folder, we have a routes folder, and we have the database.js and the server.js. Now, once again, just a reminder that at any point you can compare your code to mine via the GitHub repo. The link to the GitHub repo is available in the description down below. And if you do go and check it out, if you could star the repo, love that support, that would be super appreciated. Now, we're almost done setting up the folder directories. The last things we have to do is create the files to go within these folders. Now, within the middleware, we just have one file called auth, A-U-T-H, middleware.javascript. This is where we're going to write all the JavaScript to handle the middleware. And for the routes, as you learned in the previous tutorial in chapter 2, we had two kinds of routes. We had API routes, and then we had website routes. Well, there can actually be, a plethora of different types of routes and consequently API endpoints. And so we're just going to subdivide them in this project to auth routes.javascript, and finally to-do routes.javascript. Now, in this project, we're going to create a full stack application from a backend application where we serve up a website, where the website is essentially an authenticated, protected to-do application. It looks absolutely excellent, and we'll see how we can get that up and running shortly. But the two types of backend endpoints we'll need, well, actually three. We'll need one to serve up a website. We'll need some logic or endpoints to handle all of the authentication. And then we'll need some logic or endpoints to handle all of the CRUD operations, where we're creating, reading, updating, and deleting different to-dos in our to-do list. And so that's what these files are for. We're just going to have all of our authentication routes in here and all of our to-do routes in here. And with all of those files now created, that is our project configuration 99% complete. We're not going to do the 1% just yet. But essentially, just to summarize what we've done, within chapter 3, we have created two folders. One is called public and one is called source. We also initialize this package.json via the terminal using the npm init-y command. That is the project specification for our chapter 3 project. And we also defined a file, a REST file, which takes advantage of the REST client VS Code extension. And this file is going to be where we can emulate some browser network requests, emulate the client. So that's going to be handy for when we test our endpoints later. Now, for now, the public directory is empty. We'll change that shortly. And within the source directory, the source code, if you're familiar with that expression, the source code is basically all the code that creates our application, and that is within the source folder. Now directly within that folder we have two JavaScript files. One is the server, that's going to be the hub of our application, and the database.js is going to be for all the database configuration logic. And then finally we have two folders. One is called middleware. We're going to learn all about the middleware very shortly, but essentially what it's going to do is just handle all of the authentication between the client and the server side, between the front end and the back end. And that logic is going to go within the auth middleware.javascript. And finally, we have two routes folders, which is just going to separate all the logic out for the different types of API endpoints that we will need for this application. Now, don't stress if that's a lot of information. As we work with these files, it will all become very comfortable and familiar to you, especially as we jump into chapter 4. It's just the same thing, but slightly more advanced once again. But do make sure that you have configured this folder directory properly, because that will be important for linking between different files as we code out this project. So now that we've set up all the folder directories, the next thing we need is to add in all of the npm packages we're going to need for this project. Now the list is not actually that great, but it's not as small as it was in the first example. For this project, we're going to need to install the Express package. So we're going to use the npm install express command once again. However, in this case, we have a couple of other packages that we want to throw in. So we're going to type them all in the one line. So here we have npm install express, that's package number 1. The next one we're going to need is called bcrypt.js, just like that. And that's the library that is responsible for encrypting data, specifically usernames and passwords, and that is super important when you're developing your own authentication system. Now in this project, we use an authentication system known as JWT Authentication or JSON Web Token Authentication. Same thing. As we get to that, I'm going to explain very explicitly how that system works to create a very secure authentication system and consequently full stack application. But for now, all you need to know is that we will be needing a package called bcrypt.js, specifically because we don't want to have to write all the code to create these encryption algorithms. Now the last package we'll need is called JSON Web Token, and that is once again just another package to facilitate our authentication system. So now that I've typed out those three packages, I'm going to hit enter, and npm is going to add them to our project. We can see that was super fast, and now we have this node modules folder within the chapter 3 directory. Once again, we're not going to go touching any of those folders because someone else has coded them. We're just going to add them to our project so that we can leverage that code. If you wanted, you could check out the documentation for all of these different packages to really understand how they work, but I'm going to cover it all in this course anyway. But we can also see that these packages have been added to our dependencies list within our project specs, which is the package.json file. Now within here, I'm just going to change the description of this project. This is going to be a full stack to-do application that uses a NodeJS backend, a SQLite database, and JWT authentication. So that's pretty cool. And now with those packages installed, you might remember in chapter 2 we installed a developer dependency called NodeMon. Well, we actually don't need that in this project because one of the experimental features that is available in the later versions of Node.js is a system that essentially does the same thing, automatically reboots our server when we save or create adjustments to the code base. So that's super exciting. Now with all of that done, the last thing we need to do to boot up our application is create a script that defines exactly how npm or Node Package Manager should start up our application. Now I'm going to call this the dev script, and here needs a comma at the end. It's within the scripts field. And essentially how this is going to work is it's going to be node space, and then we're going to use some flags. Now the first flag we're going to need is env-file is equal to .env. Now historically, to add env files or use environment variables, which are the secret protected keys within a Node.js application, you used to need a package called .env. Now within the later versions of Node, it's built in, and this is how we tell Node where to look for our environment variables inside of that .env file. The second flag we're going to need is experimental strip types. Once again, this process is specifically if you are only using Node version 22, which is the experimental version of Node. As Node officially releases these features, you will not necessarily need these flags. You'll probably need this one, but you might not need the experimental flags. And then after this experimental flag, we need another one. This one's going to be experimental-SQLite. As I said earlier, if you're using a more recent version of Node at some time in the future, SQLite will probably just be built into the official release. And then last but not least, we need to specify the file that we want Node to run. And that is going to be /, because we have to enter the source directory. And then we want it to boot up the server.javascript file. Now, I actually forgot one flag in here. The last flag is to tell it to emulate the feature that NodeMon used to do, which is automatically restarting everything. And that's just a --watch flag. Now, with all of these flags and this whole command set up, suddenly you can really understand why it's beneficial to have these scripts, because instead of writing that out, technically I could write this out in the terminal every single time. But now if I save that package.json, I can just run that script using this simple command every single time. And, we can just have the magic happen. So technically we can go ahead and run that command, and that is absolutely completed, and our application is up and running, but there's nothing currently to run. So I'm going to go ahead and kill that. That's pretty easy. And now we can get to the actual code. So the file we're going to start off with is our server.javascript. And if you recall, in our previous project, it only took about 4 lines to get us up and running with a server. And the very first thing we did was we imported the Express package. So in this case, what I'm going to do is type const express is equal to, and then I'm going to use the require command, and I'm going to require the Express package, and that's going to bring it into our application. Or at least that's what we would have done in chapter 2. In this project, we're going to look at a different way of importing files and folders into our basically application. This is a more modern syntax. So in the newer versions of Node, it's now best practice to, instead of using the old require syntax, instead we just use almost a more logical syntax where we just import Express from the Express package. So this is a slightly different syntax, and this is actually one of the criticisms of Node.js, is that they jump between these different importing syntaxes, and it's a whole can of worms that I'm not really going to open up right here. But the moral of the story is that for this project, we're going to use this slightly different importing syntax. It's my personal preference. I think it's much easier to work with. But to configure our Node.js application to work with this new syntax, we need to come to the specs file and make sure that there's a little line inside of the specs file that basically configures our application to use this new syntax. So underneath the main line right here, within our package.json, I'm just going to add a field that's called type, and the value associated with that is going to be called module. Now you might have noticed just there that there were 2 options actually come up. One was called module and one was called common.js. Common.js is for the previous syntax that we were using. That's the default value. If you want to use the modular syntax, then you just have to specify this line right here. If we save that, then we're all good to use that newer import syntax throughout our project. So now that we've imported that package, we can go ahead and do what we always did, which was define our app and invoke Express. That's pretty straightforward. We're going to need a port. So I can define a port just here. Const port is equal to, and in this one, I'm going to use 5000. We'll do something a little bit differently. And the other thing I'm going to do just here is actually set the 5000 as a backup, because what I want to do is provide a value from the environment variables instead, if it exists. Now, when we define variables within these .env files, and we'll see how we can do that later, we can read them into our application by typing in process.env and then accessing the name of the environment variable, which will be port. And once again, we'll see how we can configure that shortly. But essentially what this slightly improved syntax does is it just checks if there's a port environment variable. If there is, we use that. If there isn't, then we default to 5000. And then, lucky last, we just tell our app to listen, app.listen at the port, and then we pass in a function to be executed if our server boots up adequately. And so that'll just be an arrow function where we can console.log a template literal string that just says server has started on port, semicolon, $ curly braces, and we can inject the port just there. So that's our few lines to create the boilerplate code needed to build our entire server. Now with that done, I can save that file and run the npm run dev commands. And that is going to fail to boot up our application, and that's because that port is already in use, so I must have something running on my device at that port. So I'm going to change it to 5003. I would expect that that would have worked for you. If it has, then that's totally sweet. Let me just change that backup port, and now we can see that our server has started on port 503. And we can test that that watch flag is working, because if I say console.log hello world, just throw that in there and save that file, we can see that our server automatically restarts due to that watch flag, and we print out hello world. And just like that, we have done everything we need to set up a more modern project directory. It's going to make it much easier to develop a more sophisticated backend application. We've created the code we need to configure the beginnings of our server-side application. And from here, we can really start to flesh out all of the endpoints and all of the features and functionalities of our backend application. Starting off with serving up a front end. Now currently, as with the previous project, we have started up a server on our local network at our local host on port 5003. So, let's expect we can come across to our browser and look at localhost 5003, or if you're using port 5000, it'll be port 5000. And just like with chapter 2, when I hit enter, we get a cannot get. It's a 404, which means that the browser sent out the network request to that address, and it potentially may have got there, but we didn't handle that incoming request. There was no endpoint that had method get at this particular route to receive that request and consequently respond, in this case with what we would expect to be a website. So that's going to be step number 1, is sending back a website. We need to send back a front end that a user can interact with to have a full stack experience, and that's going to be our authentication protected to-do list. So that's step 1, let's send back a website. Now the question becomes, where's the website? Well, I've got you covered. I built the website in advance, so the front end is completely developed. All of the logic is available there. I'm going to copy it across to this public directory right here within chapter 3. Now for you, you will need to go over to the GitHub code, which is linked in the description down below. Check out chapter 3 and copy across the files within the public directory. And while you're there, if you could star the repo, love that support, that would be super appreciated. So just here, I'm going to copy across the 3 files into this public directory. So there's a fanta.css, an index.html, and a styles.css. Now FantaCSS is just my little child. It's like a design library, so that just styles everything. Styles.css is all of the layout styles, so not so much of the prettiness of the application, but the functional layouts. And then the index.html is just some HTML code with some scripts and JavaScript at the bottom to handle all of the different CRUD actions and all that good stuff. So that's super important. If you want, you can totally go through and have a look at the code. There's a little bit of it, but at the same time, there's not an infinite amount. I've commented out a lot of it, so it should be pretty self-explanatory. But once again, you know, this is a back-end full course, and the front end comes pre-completed. So you just need to copy these files across. Now, as for why we're copying them into our public directory, well, the public directory is the canonical folder from within which we serve up everything, any assets from our for our project. So in this case, we need to serve up a front-end application, and consequently, here is our front-end application. So now what we have to do is actually take this, you know, these files, and when we get this network request, we need to send them all back across to the browser, and then the browser receives the CSS sheets and the HTML and loads that website. Now that should be relatively straightforward, and most of that logic is going to go within our server.javascript. Now what I'm going to do is start off by getting rid of that little console log that's going to reboot our server. And the first thing we need to do is define this endpoint, the end destination for this network request that our browser emits when we go to the URL, which when you deploy the application could be, you know, todoapp.com or whatever it might be. So as we saw in the previous chapter, defining that particular endpoint is actually pretty easy. So we can see that the method or verb is a get. So we type app, we access our server app, and we use the get method to define that endpoint. The next thing we need to provide as an argument to the get method is obviously the route. And here we can see the route is the /route. So we're just going to have the /route. And then the second argument is the callback function. That's going to be an arrow function, and that receives the request and the response as arguments. And now I can open that up onto a new line. Now we saw in the previous chapter how we can send back some code, how we can send back status codes, all that good stuff. If we want to send some files like we do in this instance, we want to send back the index.html and all that good stuff, we need to res.sendFile. Now in here, we need a little bit of code to basically determine or locate the files that we need to send. So this might be a little bit complicated, but we need to take advantage of a JavaScript module known as path. Now we need to import path into our project. That's step number 1. And that's native to Express. So we just import path from the module called path. Now there's something else we have to import from this path module. So what we're going to do is after this path, we're going to throw in a comma. And we need to destructure out this particular import. So we're going to use the curly parentheses just here. And the item we need to import is called directory name or dir name. So that also needs to be imported. And while we're up here, there's one other import we need that's also native to JavaScript. So we're just going to import. And this one also needs to be destructured. And it's going to be file URL to path from a module called URL. So that is super cool. So these are the two imports we need, and they're going to enable our JavaScript server.js file to look for the HTML files and consequently send them back as a response. So we've got those imports. Now the next thing we have to do is just above this endpoint, we need to get the file path from the URL of the current module. Now that's a slightly confusing sentence, but essentially it's just a configuration line to allow us to navigate the folder directory that we have just here from within our code. So we need to define a variable called __ file name, and that's going to be equal to, and we're going to call the file URL to path. And then as an argument, we just pass in import meta.url. So that's going to give us access to the file name. And then underneath that, we need to get the directory name from the file path. And that's going to basically tell our operating system, okay, this is the directory where the files can be found. So we need a variable just in here called const, and this is the double underscore once again, and that's called directory name. And that's equal to, and we're going to invoke dir name, which we imported above, and we're going to pass in the double underscore file name. Now, this is going to come in handy in a number of places, and we'll see all about that just shortly. But the first thing we have to do is we have to send this file, and what path does, all of this ultimately comes down to allowing our code to locate files and folders on our device or whatever device it's running on. So path allows us to construct the ultimate path to find these files and folders. And so in this case, this endpoint is for serving up the HTML file from the /public directory. And so this path, we're going to join the underscore directory name, which is basically the directory of our project. And onto that, we're going to throw the public directory, and then we're going to throw the index.html, which is specifically the file name. So this code essentially isolates our directory. And then what we do is we join together the current directory. And I think I've got one too many underscores right there. There should only be two. So I'll just get rid of one of them. 2 underscores. It joins together the directory with the public folder and consequently the file. And that's how our body of code knows to find that file that it can then send back across the network. And that's literally all we need to do to send back the HTML file. So if I now go ahead and save that, our server restarts, and I can refresh this page. And loading that website gives us one error. And we can see here, this is the ultimately resolved path name. And we can see that the issue is that it's looking for the public folder within the source directory. So there's one last line we need to add, and this is known as middleware, which we kind of saw earlier. And it's just a bit of configuration. And so we need to tell it exactly where the public directory is, because currently it thinks that the public directory is in the same level directory as the server.js, but it's actually one above. So we're going to basically add a line that serves the HTML file from the /public directory, and also tells Express to serve all files from the public folder as static files. So that's what I was talking about, the assets, is static assets /files. Now this is important because any requests for the CSS files will be resolved to the public directory. And we'll see exactly how that works in just a second. So we need to throw one little line in here. It's just a little bit of middleware. It's part of configuration for our app. So we just say app.use. And in this case, we use an express method. So we access express and we tell it to use the static method. And basically this is saying, okay, where do we serve the static content from? Well, it's from the public directory. So we call path, we join once again to create the ultimate path or the absolute path for the public directory. And we just go from the underscore directory name again, and onto it we add the double dot /public directory. So that basically says, okay, you can find the public directory, but it's actually not within the source directory. It's one up, and that's why we have the double dot, because that's how we go up a level of folders. So if I now go ahead and save that once again and refresh the page, we can see now we actually get back the website. So this is the endpoint that literally serves back the file, and this is a configuration line that basically says you can find the public directory, not quite where we are right now, but if you go up one level, that's where it'll be from. So the express.static line basically is used to tell our code where to find the public directory. And the public directory is what serves up all of our assets. So that's really cool. We've literally actually sent back a website where in the previous chapter we just sent back some HTML code written as a string. Now, one thing we'll note, if we right click and inspect and then come across to the network tab, we can see that when I hit enter, a bunch of requests are sent. First is the local host, and this sends back the HTML file, which itself doesn't have any styles. It's not a styled file, and so here you can see the unstyled equivalent of this web page. And that's set back as all this HTML code. However, at the top, we have these links. Now, when there's a link, essentially what happens is the browser goes out and fetches the information at that link. So we can see there's a /styles and a /fanta.css sheet. So it consequently, our browser went out and sent those requests out, fetching the CSS files. So here we have this styles.css sheet, and that's the URL it went to fetch it from. And because of this line, our app knows to serve up these files from our public directory. And so that's what it got back. It previewed, it got back all the CSS, and then it could apply it. And it did exactly the same for the fanta.css sheet here. And consequently, we load a styled application. This is the authentication page. It's super responsive, looks pretty nice and neat. So that's hunky-dory. We now have a website, a front end, being served up from our backend code. Now the front end is super cool because when we can later authenticate, it's wired up to send out all sorts of network requests for all sorts of different interactions, logging in, registering a new user, create, read, update, and delete different to-dos and all that good stuff. And that will just allow our browser to send out all of those network requests that will reach the different endpoints that we'll code throughout this tutorial that are going to go in these routes just here. But this code just for sending up this home website is definitely some code that we can have within our server.js. Now, the one other line I want to add before we move on to some of these other endpoints or these routes is just one that allows our server to receive JSON information when it receives network requests that have the method of post or put potentially. If you recall, that's something we did in chapter 2 to enable our endpoints to actually interpret that JSON data, which could be a username, it could be a to-do or anything. So whenever the client is actually sending information instead of just asking for something via a GET request. And that's just one other line of middleware. So this is going to be the middleware right here, this app.use, and we're just going to add one other line of middleware. And that's just going to be called app.use express.json. So that basically just configures our app to expect JSON and consequently enables it to pass or interpret that information. So we're just going to throw that in there as well. And I'm actually just going to move that up directly under the middleware line above this other one because this is specific to this line here. Now, once again, if you're wondering how I magically move that line around, I've got a link to all of the VS Code shortcuts that I use in the description down below. There's a website I made that basically tells you all about them. And just like that, we're almost done with our server.js. Most of the code that we're going to write from here is going to be within all these other routes. So now that we've just about done all the logic for our server, the next file I wanted to get started on is the database, because we're going to need our database up and running if we want to do any authentication, if we want to have any data storage, and we can get started on that by heading into the db.js file. Now this file is actually super simple to get up and running. The first thing we need to do is import SQLite from the NodeJS package. And the way that we do that is we import, and we need to destructure out this particular import, and it's called database sync. So it's a synchronous database, and we import that from node semicolon from the SQLite package. Once we have that imported, we can go ahead and just like we created our app with Express, we create a database by creating a variable called db and setting it equal to, and we have a new synchronous database And in here we pass in a string, and that string, as you can see just here in the documentation, is going to be an in-memory database. And so that means we don't have to manage any external files. And so we're just going to have the semicolon and type memory. Now this isn't what you would use for a production database. We'll see how we can configure that in the last project in chapter 4. But if you just want to get up and running with a SQL database, then we're just going to use memory for that, and that will be more than adequate. So now that we have our database, the next thing we need to do is basically set up our database when we boot up our application. Now for that, we need to execute some SQL statements from strings. Now the way that SQL works, or structured query language, is you can almost think about it as an Excel spreadsheet where you have different columns and different tables, where a table is kind of like an Excel sheet. So you can have different sheets for managing different data. Now, unfortunately, when we first create our database, none of these sheets exist, or none of these tables exist. The table is the literal term for it. So in this case, we're going to have two different tables where each table is like a sheet. One table is going to handle our users, and then the other is going to handle all of the to-dos. And for every to-do, it's going to associate them with a user. Now, to actually make this happen within the database, we write commands using the SQL language. And using this node package, we can get our JavaScript to execute these commands and configure our database. So what we're going to do is we use the database.execute method. That's going to execute a SQL command and act it upon our database. Now that takes a template literal string, as that's going to allow us to write some strings across different lines. Now the SQL command to create a table, where once again we need two tables where each table manages different data. One table is specifically for users, and once again you can just think of that as like a tabular database, like an Excel spreadsheet. We need to actually create it, so we create a table called users, just like that. Now after we create the table, we need to specify some of the different columns in our table. So we have these circular parentheses, and we're going to enter the circular parentheses on some new lines. Now in here, we enter the different columns and we specify what kind of data type they're going to be, in addition to some other information. So the first field is going to be an ID. Now the ID is going to be of type integer. So that by itself is pretty straightforward. After that, we're going to have a comma, and then on the next line, we're going to need the username, and that's going to be a text field, and it has to be unique, so we can throw the unique key onto it. And then lastly, we have a password field, and that's also going to be of type text. So this SQL command right here is going to be executed upon our database, and that will configure that table so that our database is up and listening and it's ready to accept the new users, where each user has a username and a password, and that gets saved to the database. Now the second command we're going to need is for our second table, and that's going to be for all of our to-dos. So we're going to have a database.execute, and we want to execute a SQL command. I'm going to open that onto a new line, and this one's going to be very similar. We're going to create another table, which once again is just like a sheet, and this one is going to be called to-dos, and then we're going to have the circular braces, where in here we're going to specify the different columns. It's pretty straightforward. The first one is also going to be a unique ID. The ID is the best way for referencing different lists or different elements in the table. And that is once again going to be an integer field. Then we have a comma for the next column. The second one is going to be a user ID. Now this field is going to also be an integer field, but more importantly, it's going to be the field that associates it to do with a particular user. So every user is going to have an ID right here, and the user ID field is going to keep track of which user a to-do is for. And that's super important so that when someone authenticates, they only receive to-dos that are specific to them. Now, to create this level of communication between tables, we need to essentially configure a field to be what's known as a primary key. So what that means is that in this ID field here, since I'm saying that the users table needs to be able to be referenced from other tables, and we're going to reference by the ID, we need to set this key up to have superpowers and essentially create it as a primary key. So we use the field's primary key right there, and that's going to set up this ID as like a superpower key that can be referenced within other tables. So such as the to-do table right here. Now the last element I just want to add onto this one is called auto increment. And that's because when we create a user, we're not going to specify an ID. We want it to be automatically assigned to the new user. And we just want them to auto increment. So our first user is going to have the ID of 1. The second user is going to have an ID of 2. Now all of the SQL stuff will become more and more clear to you as we continue to use it. And also as we actually look in the database as we create all of these interactions. And finally in chapter 4, as we build out a more complex database and literally start interacting with it. Obviously, in both of these applications, using the application will save data to the database, but there's like basically hacker ways that you can override it and work in the background, and we'll see how all of that works, and it should be a really beneficial experience to help you understand exactly what's going on. But anyway, the moral of the story, what happened there is we have this user ID, which associates a to-do entry with a particular user. But to allow that communication method, we need to set up this ID to be a primary key so that it has superpowers so that we can reference it from within other tables. So now we have this integer field, and this one right here does not need to be a primary key because it just refers to this primary key. However, the ID of the to-do, every to-do also has its own unique ID. This actually also is going to be set up as a primary key, and we'll configure it so that it auto increments. After the user ID field, we obviously have the task, and that's just going to be a text type. And then we have a completed status, which is going to be a Boolean yes or no. So it's either complete or it's not complete, and that's going to track the status of it. And that is going to have a default of 0, which is going to be false. So we're going to use a numeric value to track the true or false state. So 0 is false, 1 is going to be true. And finally, we have a foreign key, which is going to be the user underscore ID. And that is just going to reference the user's ID field. So that's obviously quite a few SQL commands. Once again, this is a backend full course. We're definitely not giving SQL the attention it deserves. The SQL ecosystem is incredibly, sophisticated, and you could spend 100 hours looking into it and becoming more and more competent with SQL. But for now, we just need to configure the tables. And as I said earlier, when we start going behind the scenes and modifying our SQL databases using SQL commands, all of this will become much clearer and apparent to you. But for now, we just need to get them up and running. So if we go ahead and save that, that's the code we need to create our two database tables, set them up with some columns, and give them the means to communicate and reference one another. Now the last thing we need to do from this file is have a default export of DB. And this line right here is going to allow us to interact with this database file, this database variable, from other folders and files, such as from within our server, such as our auth routes, our to-do routes, and our middleware. And as you can see, it also allows us to keep a very tidy project directory because, I've got 23 lines to configure an entire database, which is super sleek. And now I can quickly know where to reference that code. It's not all just jammed into one file. Everything is compartmentalized. So with our database created, it's time we start setting up some endpoints to manage our authentication, which is going to be step 1 of getting this front end working properly with our database and backend. Now, just before we jump into our auth routes and the next section, I noticed there's one little error I made in this particular file. So we've configured our database so that when we boot up our application, it basically creates these tables where we can then save all of our data. However, when we reference between the two tables, when we assign a user to a to-do or associate a to-do with a particular user, we're referencing the users table. However, we only named it user, so that just needs to be pluralized, and we can go and save that, and that is now fixed. So for the next step, let's actually come back to the application, which is now being served up. I refresh the page, this is what loads, and let's try enter a user. I like using testemail@gmail.com, and I just do a password. It's a couple of digits. And now let's see what happens when I click submit, having this network tab open. So I click submit and I get an error showing up. And if I look at the network tab, we sent out a request to, let's take a look where. Let's have a look at the headers section. Here we have the header. It's got the general information, including the URL. And this is the endpoint that we sent this network request out to from the client to the backend. It was a post request, which means that it contains a payload. And that's got a username and password, and that is specified as JSON information. And we did configure our server to pass that information with this line here. We said to our server, expect this JSON information. However, even after having done that, we got a 404, which basically said there was no response. We didn't hear anything back, no idea what happened. And that's because we don't have an endpoint set up for this particular route, and that's why we got the 404. So what we need to do now, if we want to log in a user, or let's say I want to sign up instead, let's go and submit that to the registration endpoint. We need to create both of these endpoints, because right now we're getting back 404s because they don't exist. We haven't made them. And they are the endpoints we're going to be creating within this authroutes.javascript file. Now, obviously, it's super fun to use this interface to be able to send out these network requests, but we're going to also do the exact same thing from our client emulator, which is this to-do app.rest. But we'll see how to do that very shortly. First, let's actually create the endpoints, because there's no point in emulating these network requests if there's no code to receive them. So from within the auth routes, this is where we're going to define all of these endpoints for handling the authentication functionalities. Now in here, we need to do a few things. One is we need to import Express from the Express package. Two, we need to import bcrypt from the bcrypt.js package. Now, if you recall, bcrypt has all the code for encrypting the passwords and creating a truly secure application. And as we come to this code and implement it, I'll explain a little bit about how the encryption algorithms work. We also need to import a package called JWT from JSON Web Token. And that's just going to allow us to create a JSON token, which is just an alphanumeric key that is essentially a secure password that we can associate with a user to authenticate them when they make future network requests, but without needing them to sign up again. So that's going to be important. And the last thing we need to import is our database. And that's going to be from our db.js file, ensuring that we have the path to this particular file correct. And we can do that because we're exporting the database from this file, which means that we can import it into another. So these are the four imports we're going to need. The database is obviously because if we're registering a new user, we need to write that new user to the database. And if we're logging them in, we need to check the database to see if that user actually exists. Now, one new concept we're going to introduce here is how to configure endpoints or routes when you're not defining them in the original file. If we come back to chapter 2, just here, I made a whole lot of endpoints in this server.js. It was pretty straightforward. We just called our app and we configured the endpoint for the method and the route, and consequently wrote the logic to respond. And obviously that works. We've already done one example of that with this endpoint right here, this home get endpoint that serves up our HTML website. However, when we're subdividing or compartmentalizing our routes into these sub-files, we need one extra, basically, configuration layer. And so what we're going to do is define something called router. It's a variable called router, and that's equal to express.router. Now the reason we do this is because what we do from here is we export our default router, and that needs to be a lowercase r, in our main application, just in here, what we can do within the server.js is we can define a section here called routes, and instead of writing out all of our endpoints, we just say app.use, and for any authentication routes, so any routes that are within this path, we just use auth routes. Now auth routes is an import that we need, so we come up to the top just here. We're going to import auth routes from ./routes/authroutes.javascript. So there's a few steps there. Let me just go over them once again. Obviously, we just got an issue right here. Cannot find this particular module. Routes/authroutes. We'll get to that in a second. But anyway, the moral of the story is that we, inside of authroutes just here, create this router. And it's to this router that we're going to assign all of these methods. So it's basically like a subordinate app, or like a subsection of our app where we can create all of these methods. So for example, I'm going to have one method that is a register method right here. So it's a post request to the register endpoint, which if we look just here, this is the post request to the register endpoint. And we're not throwing in this /auth route on the front, and we'll see why in a second. It's just to the register endpoint. And then just as we have been, I can provide a second argument, which is the request and the response. And that is the function to be executed when some code hits this endpoint. Now, when we export this router and we import it into our server, ensuring that I save it, and then we use this line right here, it basically takes all of the routes that we define for the auth routes, and it slams them on the end of the /auth route. So it combines basically the paths or the routes. And so that will define this particular endpoint. So we've got the /auth, and then all of the endpoints we define within our auth routes will just be these sub routes within that. Now we've got an issue just here that says we cannot find the module DB. So that is within our auth routes, and I think that just needs to be db.js instead. So let's save that, and now that's working perfectly. So what we're going to do inside of this authentication routes section, we're going to create two endpoints. So instead of using the app, now we're using the router, and that just allows us to subdivide all of our endpoints and routes into these nice little files. And so we're going to have a secondary post request, and this one is going to be for /login. And that's once again just going to have a callback function that receives the request and the response as an argument. And this is going to contain the logic to log in a user when we hit that endpoint. Now when we save that, these two endpoints that we've defined in here are added to this router, which is exported from this file. And then in our server.js, we import all of that as auth routes. And then we just slam that on the end of any /auth requests. We tell our app to use all of these auth routes when we hit endpoints that contain the /auth route. Now the exact same thing is going to happen within the to-do route, so we may as well just configure that before we actually get into the nitty-gritty of defining all of the routes. So in this to-do routes file, we're also going to import Express from the Express package. We'll also need our database, so we'll import the db from /database.js. Then we'll define the router, which allows us to create these specific routes within these sub files. So router is equal to express dot router, and then we can just have a router dot get method, and this is going to be to get all to-dos for a user. So this one, get all to-dos for logged in user, and then we just have the request response, set that up. That's going to be an arrow function. Then we need another one. This is going to be to create a new to-do, and in here we're going to have router.post, because if we're creating a new to-do, we're not just asking for information, we're actually sending over what the new to-do is going to be. That's going to be some information entered into the front end that's sent over the network as a network request. Our backend is going to receive that post request, and that's going to be to the /route, and then we're going to have the function to handle that and consequently save it to our database. We'll need one for update a to-do, and so this one is going to be a put method, which, if you recall, putting is for when the network request wants to put information in the place of an already existing thing. So post is for creating and put is for modification. So this is going to be to the /. Now, the route for the put is slightly more complex. If you recall, within the database here, when we create a to-do, all of them get an ID. Now, if we're updating a to-do, the way that we do that is we update the to-do with the ID that matches the ID of the one that we're updating. So we check the database, we match up the IDs, and then we make the modification specifically to that task. So that means that when we send out this request, we actually need to specify the ID. Now, one way we could specify that ID is by posting that as JSON, but another way is by using a dynamic query parameter. Essentially what we do is we use the semicolon, and then we provide the parameter where, if I actually created the request, I could use ID of 3 in the place of this. Now we'll see how all of that works when we go and create, or when we create the emulations of all of these network requests. But for now, this is just a dynamic ID, which is going to allow us to identify exactly which to-do we need to make the modifications to. Now in here we still have the callback function, or the function to be executed when our network request hits that endpoint. We'll still have a body of information that is sent over as JSON, but we just specify the ID just here, so that's nice and neat. And then the last one we need is to delete a to-do, and that's going to be router.delete, and that is also going to be to the ID parameter, or ID path, and that's going to allow us to basically say only delete the to-do entry that has this particular ID, and that's also going to have the function. Now with all of these endpoints done, obviously we'll come back and create the code for each of them later, but I'm just going to export default the router. That's going to assign all of these endpoints to this router entity, and then once we've exported it, we can save this file and come into our server.js, and we can import from the ./routes folder, and then consequently the to-do routes.js, and I'm going to import these as a variable called to-do routes. Now the name that I use to basically assign all of these imports to doesn't have to match the one that was exported from the file. So in both of these cases, I've exported a variable called router, but when I'm importing them, I'm importing the value and assigning it to this name, essentially, so to-do routes. And now what we can do is we can just duplicate this line right here, except in this instance, it's going to be for routes that are to the to-dos endpoint. And ultimately we can see with this configuration, it's just going to allow us to have a whole lot more endpoints, but basically subdivide them into their own files, which is just going to keep everything a whole lot cleaner. So that's super nice and neat. And technically we're actually finished with our server.js file. Everything from here is just filling out all of these routes and their functionalities. Now that's actually a lie. There's one last thing we need to do, and that is add some middleware to the to-do routes, because when we assign them, we have to throw in some middleware that authenticates a user before they can actually have access to those endpoints. So we'll come back and make one little modification to this line later, but that should do it for the minute. Now, one little error we just need to clean up real quick is in the server, I noticed that this was not we're meant to assign the to-do routes to this /to-do route. So now that we have all of this code done, we're ready to go and fill out our endpoints. The next thing we're going to do is actually create the emulations for all of the functionalities. Now the reason we do this is because obviously when a user uses our complete application, they're going to be able to do all of it from the user interface. However, while we're still developing our application, it can be useful to basically predefine all of these interactions, and we'll set them up in here. And that way we can emulate these functionalities as if a user was using our application, and we can ensure that our backend is set up to handle everything. Now this process is kind of analogous to running tests in JavaScript or any particular programming language. Where testing works in a similar manner. Essentially you just basically think of everything a user could possibly do, and then you create those actions programmatically. And then you can be sure that they are working adequately. So the ones that we're going to start off with are the authentication routes. Is the first thing the user would come in and do. They're going to have to register a user. So I think that's a good one to start off with. And so what I'm going to do in here is I'm just going to add in some triple pounds inside of our to-do-app.rest, and they're going to separate the different emulations. Now I actually lied. The first one is going to be the get/endpoint, and that's going to be to check that the website loads. So when a user hits this endpoint, they are sending out a GET request to the http://localhost, and then our app is on, for me it's port 5003, for you it's potentially 5000 or whatever other port you specified. And so they're going to enter this URL and they expect to get back a website. So we can now go ahead and test this endpoint, and we see that we do in fact get a successful response. We get a 200 response, which means success, excellent. And we can see just here we have all of the HTML code that if we did this via a browser, or if a user did it via a browser, would then be interpreted by the browser and rendered onto the screen, and all of the JavaScript would be run. So that's pretty cool. That's our first endpoint setup, and it's working. We've created an emulation for it, and we can see that that communication between the client emulator and the backend is successful. Now the next one is for registration. So what I'm going to do to test exactly how the registration works is actually come over to the index.html, and we're going to look at how the client or the front end actually creates this registration network request from the browser. And this is also going to be beneficial if you wanted to come and fiddle with this front-end code. It's pretty self-explanatory, but we're just going to run through it together. So let's look for the function that registers a user. Here it is, authenticate. So if we come down, we see this line of code just here. Obviously there's a bunch of guard clauses up the top that basically just say if a user doesn't have a username or password, then let's not even bother sending out a network request. But we check to see if the status is registration. And if it's true, then this code right here is the code that creates that network request via the fetch API. And here we have the URL or to which we send this network request. So we can see that the endpoint is /auth/register. API base is just up here. The API base is the local host. In this case, it would just be / because it matches the host from which we serve up this front end. Now, if we look at the network request, we can see that the method is post. We can see that we specify the content type, and we can see that we have a body which contains some JSON, which is originally an object, and that contains a username and a password field. So what we're going to do is literally just create these three fields from within our client emulator. So first up is the method. It's a post request, and then we provide the URL. So that's going to be http//. /localhost 5003, and then that's to an auth route and a register route. And together that creates that specific endpoint. And if we check our server, we can see that all of our auth routes go to the /auth route right here. And then within our auth routes, we can see that we then have the register endpoint, and this is the endpoint that we would expect to receive this network request. So that's the post request setup. Now, if we're posting information, we need to actually create that information, and that's going to be a JSON object right here. And that has two fields. It has a username, as we saw. I'm just going to leave that as an empty string for a second. And then we also have a password field. And that is also going to be an empty string. And that's just set up like an object, except we ensure that all keys are stringified using the double quotations. Now, just for formatting reasons, it's important that we keep a space above the JSON that we're creating for this network request. Now, the last thing we saw inside of our index.html is that we had some headers where we specify the content type to be JSON. So we just have to do that as well. That's what our front end would do, so that's what our emulator has to do. So in here, we're just going to specify the content type parameter, and that's going to be application/JSON, not JavaScript. Just like that. And so now we have set up our client emulator to emulate that network request as if it were a user actually using the front end. And since we've created that endpoint, we should be able to send this request. And because within that particular endpoint, which we have right here, we don't have any code to respond, what will actually happen is the network request will find this endpoint. The endpoint exists, and it will just wait indefinitely. It will wait for a response, which it never gets, and typically there is a timeout associated with receiving a response. And if the timeout is reached, basically we don't get a response within a period of time, then it will default fail that request. And that will take a second. And that's opposed to if we hadn't defined this endpoint, we would get an instant 404 saying the endpoint itself actually doesn't exist. So now if I send that request, we can see that we just sit here waiting for a response. Nothing's happening, and that's because the code has hit this endpoint, but we don't get a response back. So we just sit waiting indefinitely. Now, because that's not what we actually want, but we have confirmed that we're reaching this endpoint, we can cancel that little network request, and we can start defining some of the logic to register a new user. So the way that this works, first what I'm going to do is just comment that this is a register a new user endpoint, and that is the /auth/register route, and it's obviously a post request. Now, the first thing we need to do if we're registering a new user is our backend receives this network request. We need to figure out what the username and password associated with this network request are. We know they're posting information, and when we post information, specifically as JSON, that is always contained within the request, the incoming request, and it's associated with the body key. Now, once again, this particular line right here allows us to read that JSON body of the incoming network request. So what we can do is we can say const body is equal to request.body. And that's going to give us access to the JSON body of the incoming request. Now, one thing I'm actually going to do is save ourselves a step right here. And instead of creating this variable body, from within which we would have to access the username and password key, I'm actually just going to destructure out the username and password directly. And so now if I wanted to console.log the username and the password, and for the second we can end this communication system and just confirm that it's working by res.send status, and we can send a 201, which would be typical for creating a new user. So we can now test the completion of this communication cycle from client to backend and back to the client. And the reason I want to do this is I just want to confirm that I can in fact access the username and password, which we will then need. And I also want to confirm that we can successfully respond to the network request. So let's go ahead and save that. That restarts our application, and I can now emulate this request. Now notice just here, I am printing a line, but I'm not actually getting anything out of it, and that's because I'm a numpd, and I haven't associated any values. So let's go ahead and throw in some values here. Let's just say the username is gilgamesh@gmail.com. I'd be so curious to see if that's someone's actual email. And I just like doing 123 123 123 as an easy password. And now, and just before we can see that we did in fact get back a successful request, but I really want to console out the username and password. So I'm going to rerun that. And we can see now that we do in fact log from the backend in the backend terminal, in the backend console, the username and password. And that implies that we can access this code inside of our auth routes and save it now to register it to our database. So that is super nifty, absolutely excellent. Step 1 complete. Now while we're here, I'm just going to do the exact same thing underneath this other pound key, except this one is going to be for the login route. And that is just going to mean that once we've created the login code, login backend code, we should be able to emulate the registration and then emulate the login actions that quickly, as opposed to faffing around with a front end. And that is actually the beauty of API endpoints. When you get more accustomed to them, sometimes it can actually be convenient to cut out the front end altogether and just do it programmatically via an API. But obviously, if you're having a to-do application, then it makes sense to have a front end to do that. The one thing I want to do before I exit this file is just explain what these endpoints do. So this is to register a user. And that is a post to the /auth/register route. And I'll do the same for the following one. The triple hash key basically creates a code comment. So this is going to be login a user to the auth/login route. So we've finished our emulations for these routes. Let's go and dive into the code. So now that we're ready to write the logic to register a user, it's time to get technical, and let's talk about security in developing a full stack authentication protected application. Now, one of the biggest oopsies companies make is they get into the habit of when a user creates, a new account with a username and a password, they save the username and the password to the database. And the problem with this is that if they got hacked for any reason, suddenly everyone's password is exposed to the world. Now, usernames aren't as important as long as you don't have both the username and password. So what we do instead of just verbatim saving people's passwords as a string to a database is we encrypt them. And the way that we're going to do that is with this bcrypt package. Now, the thing that becomes challenging as an outcome of encrypting every password is that when we go to log in, we look up the username and we check the password, and we need to see if it matches the one that they've just entered. The problem is, when we look up in our database the password associated with the user, we only get back the encrypted one. Now the problem with that, you might say, well, why don't we just decrypt it? These encryption algorithms are one way. Now there's a whole lot of technical information that explains exactly how that system works. I'm not going to dive into it, but the purpose is that you can't actually decrypt that password, and that makes it so incredibly secure, but it also means that we can't match the password in the database with the password that's just been entered, or at least that's what you might think. So just to really give you an example, let's say just here, we get this username and password, and then we save gilgamesh@gmail.com. And as the password, we end up with some long series of keys like that, and it just looks like mumbo jumbo. And this is what we save to the database. So let's just say we save the username and an irreversibly encrypted password. So that's what gets put in the database. Now when we log in a user, we get their email and we look up the password associated with that email in the database. But we get it back and see it's encrypted, which means that we cannot compare it to the one the user just used trying to log in. So what we have to do is, again, one-way encrypt the password the user just entered. Now, the encryption algorithms are deterministic, which means that when you encrypt a particular word using a particular key, encryption algorithms always have a key associated with them, and that's basically just a way of them to create mumbo-jumbo consistently. And so what we do is when a user enters a password, if we encrypt that using the exact same algorithm, it will get to the exact same outcome. And then we can compare the two encrypted passwords, and that's how we authenticate a user. Now, security is a whole big topic, and I really just did a 5-minute overview. As we practice it and implement it, it will become more obvious, but yeah. On the whole, essentially what we do is we use a special key, we encrypt a password, we save it to the database when a user registers, and we do that so if we ever get hacked, the passwords are totally meaningless because they're encrypted irreversibly. When a user logs in, we take the password they've just entered and we encrypt it using the same algorithm, and that, because it's deterministic, will produce the same encrypted key. And if they're exactly the same, we know that the password the user just entered must have been the one they used when they registered their account, and therefore they are equal and the user is the correct individual. Now, the way that this works from a programming standpoint is the first step we need to do is to encrypt the password. And so what we do is we say const hashed password, we create a variable called const hash password, and that is equal to the bcrypt library. We're going to use it to encrypt our password, and we use the hash sync method, and we put in the password and we provide a secondary key, which is the salt, which here we can see in the prompt, the salt length to generate or salt to use defaults to 10, and that's just going to help us synchronously generate a hash for the given string. So in this case, we're going to use the value 8. Now we need to use that consistently as well. So now we have an encrypted password, and I could actually console.log the hashed password just here and remove this other line, and now we could emulate that request and see what the hash password looks like. So let's go ahead and run that. And here you can see this is the hashed password that we would save, the encrypted password we would associate with a user, and this is irreversible. So if our database was hacked, no one could ever undo these encryptions and figure out what the passwords originally were. And so that's what we securely save to the database instead of just saving the plain old string that a hacker could totally take advantage of. So now that we've done that, we can come back to our auth routes, and we now have a hashed password that we can save to a database. Now, when we're interacting with a database, in production environments, typically a database is actually a separate server entity. In this case, we're having it all within the same server entity, and there's nothing wrong with that. It's great for development. In Chapter 4, we will separate them into their own backend entities. But because in production, basically, we're creating a new communication bridge or system. So now we have front-end, server, and the database. I like to throw this code inside of a try-catch block where we catch the error, and that's just going to allow us to handle any errors we might encounter in this process. And that's super important for having a functional, robust backend. So in here, I actually like to do the catch case first. What we're going to do is we're just going to console.log the error.message if we get a message, and we're actually going to respond to the user. We're going to respond and send a status of 503. Now, if you remember, 500 level codes, which are between 500 and 599, mean that the server has broken down somewhere in this process. And that's exactly what would have happened if we fail to save a user to the database. So let me just add a line here. This is going to be to save the new user and hashed password to the DB. So we send back the status. Now, one important thing to note is that if we send back this status, we can't then send back another status. That's going to give you an error. There can only be one status, one response, and so we're going to either send back one if we bug out the code, or if we successfully run this try block, then we'll send back a 201. Or actually, we're going to send back a token. We'll see how that works in a second. So as for the logic that we need to save to the database, well, what we're going to do here is actually run some more SQL queries. So the first thing we're going to do is create a variable, and it's going to be called const insert user. And that's equal to db, and we run a prepare method. Now the prepare method is pretty equivalent to the execute method right here, exec, where we basically just run a SQL query. However, the prepare method allows us to inject some values into these SQL queries. So what that actually looks like is we write a SQL command right here, and the SQL command to add an entry to an existing table inside of a database is we say insert into, then we specify the table within the database, so that's going to be the user's database. And then we have some circular parentheses, and in here we have a username and a password. Those are the two columns that we want to insert into. If you remember when we configured this, we had the fields username and password. Those are the two columns within the users table. The ID is automatically assigned, so we don't have to worry about that. So we're going to insert into the users table, specifically the columns, username and password, and then we specify the values. And in here, that's just some circular parentheses, and for the minute, that's going to be a question mark and a question mark. So that's going to prepare the SQL command that we're going to run. And then what we do is we define a second variable called the result. And this logic is a little bit specific to the SQLite database that's part of the Node ecosystem. But now what we do is we take the prepared query and we run it, but we call run as a method and we pass in the values that we want to save to the database. So in this case, it's the username, which we destructured out of the incoming request, the body of the request, and the hashed password. So just to summarize those two lines, we first prepare a SQL query, where this is just our SQL query. We're to insert data into a table that exists within the database. We insert into, then we specify the table, and then we further specify the exact columns to which we want to add information. So we want to add information to the username and the password columns. And then we specify the values, and we basically leave them as blanks until we then run that SQL command, and then we provide the actual values which will be injected into these places, and that will be sent into the database. Now, one thing I like to do just in here is when we register a new user and consequently create a new user in the database, I want to give them a default to-do. So I actually want to create a to-do for them that will then be shown on the screen. And that's just going to basically give them, an entry in their to-do list to prompt them to create some more and understand how the application works. So now that we have a user, I want to add their first to-do for them. Now in this case, the to-do or the default to-do that I want to add is going to be called const default to-do, and that's equal to a string that just says hello exclamation mark and says add your first to-do. And we can kind of see how that is just going to, technically it's a to-do, and I'm actually going to change that for a smiley face. That's technically a to-do. They can complete it when it's done, and that's just going to prompt them to create some more to-dos. And now that we have that line, we can create a variable called const insert to-do, and that's equal to database.prepare, and we prepare another SQL line or command. So that's going to be the template literal string. And inside here, we're just going to insert into the to-dos table. And then inside the circular parentheses just here, we're going to specify the columns to which we want to add information. So if we come look at the schema for the database, we can see right here, we have the ID, that's automatic. We have the completed status, that's automatically assigned. It's default to incomplete when we add a new to-do. So the two fields we need to specify are the user ID that the to-do entry is going to be associated with and the actual text for the to-do. So in this case, we're going to enter information into the user ID and the task columns, and those are going to have the values, and once again, that's just going to be a question mark and a question mark. So that's going to prepare the SQL query, and then we're going to go ahead and run it. So we're going to just say, in this case, we actually don't need to assign it to a variable. We can just type insert to-do.run. And now the first entry we have to provide as an argument to this run method is the user ID. And the user ID can actually be found from within the result of creating the first user. So we can in here get the result, and we can access the field called last insert row ID. So what that does is when we get back the result, we just check the ID of the last row or entry added to that table, in which case it's going to be the ID associated with the most recently entered new user. So we get that ID, that's the ID that we want to associate the to-do with, and then we just provide the value, which is going to be the default to-do. And that's going to go ahead and insert the to-do. And then the last thing we need to do, now that we have within our database added the user to the users column and created their very first to-do, is we now create a token. Now the token is super important because once we log in a user, they are then in a position to create new to-dos, update to-dos, delete to-dos. But those to-dos are specifically associated with that user, and we can't let them modify everyone's to-dos, just theirs. So whenever they run those actions, whenever they try to add a new to-do, we need to associate a special token or key with that network request that confirms they are in fact an authenticated user. So this is kind of like an API key in a sense. We create a token, and in this case, the way that we do that is we say const token, and that's equal to JSON web token dot sign. And in here, we pass in an object, and the object has a key ID, and that's just the result dot last insert row ID as we had just up here. So we get the ID of the most recently added user. And then the second value that we have to provide to the signing method is an environment variable, and this is a secret key. So what we're going to do is we're going to say process.env, and that's going to read the environment variables file, and then we're going to access the JWT _ secret key. And then finally, we're going to have a third argument, and that's going to be an object, and that's just going to have a value expires in, and the associated value is going to be 24 hours. So that means that the special token that a user can attach to their network request will expire in 24 hours, at which time they'll have to re-authenticate to gain access to a new token. Now, as for this JWT secret, we don't have it yet. Now, this is a secret key that only we know, and because it's a secret key, our immediate first thought is to throw it in the environment variables, because if people gain access to this key, they're one step closer to decrypting all of the passwords and being able to basically fraudulently act on behalf of a user. So in here, we're going to create this environment variable called JWT secret. The name needs to match whatever we throw on the end of process.env. So that name here has to match. So we're going to create this key inside of our environment variables, and we're going to set it equal to, and in this case, it can just be a string. It can be any particular string. So I'm just going to say your _JWT _secret _key. You could fill it out with anything. That's going to work for us for the second. Now, one other value I want to pass in here is a port, and I just want to set that equal to 5003, and that means that our server is actually going to use that port instead of defaulting to the 5003. So now that we have that done, we've created this token. We now have to send it back to the user. So we just say res.json. That's going to send back some JSON as a response. And in here, we provide an object and we use the key value of the token. So this syntax right here is going to create the key token and assign the value associated with this new token. Now, what happens when we emulate this request? We've finished with the logic for this particular endpoint. We add a new user, we assign a default to-do to that user, and then we create a special token that we can use later to confirm they are in fact the correct user. Well, let's go ahead and emulate this request. So I go ahead and run that, and we can see that we have now added a new user to our database, and we get back this special token that looks a little bit like the hashed password we assign to the database, but it's actually not. It's a unique token. And this token contains all sorts of information, and essentially what the front end does is if we look at the logic, let's close that and open up the index.html, we can see here we get back some data. So we receive the JSON, we basically pass the JSON and we assign it to a value called data. Now this is all within the front end. And then if the data contains a field called token, we save that token to the local storage, which is basically a client-side database. It's how all data is persisted on a front-end only system. It's kind of like a cookie. If you ever get asked, do you want to save your cookies? It's a similar concept. It's saved to local storage so that we can consistently access the token even if we refresh the page or reopen it a day later. And then if we have that token, we then fetch all the to-dos associated with that token. Now, in this case, if I come across to my application just here and go into the local storage, we don't yet have a token. But this is eventually where that token will be saved. But if we once again come across to the index.html, and now we go down to the fetch to-dos, we can see that when we fetch these to-dos, which are going to come to this particular endpoint within our to-do routes, we're going to get all to-dos associated with the user. That code comes right here in this fetch to-dos function within the index.html. We can see the fetch API is used to send out the network request. We send it to the to-dos route, and we assign some headers with it. Now, in this particular fetch request, I don't specify the method, but by default, it's going to be a get request because we're getting information. Now, what we do within the headers is we specify for the authorization, we add the token. And then when this network request is sent out, with the token encrypted within the network request, we then receive that endpoint right here. However, eventually it will be intercepted by our authentication middleware, which is going to basically check that the token is for a valid user, and then we'll only send them back to-dos associated with that particular user and that particular token. Now, I recognize that's probably a mountain of jargon, a whole lot of new concepts. If it feels overwhelming, absolutely don't stress. When we code all of these systems out and really get a good understanding of what does what and how it all works and how it comes together, it will become much, much clearer. But anyway, that is our first authentication endpoint done. The login one is fairly equivalent, and that's what we're going to jump into now. And we should be able to check that they have worked and are working successfully from within our client emulator, and we will eventually just be able to register a new user and then log in a user. All right, so we just finished up our registration route. That's all working. We tested it with our client emulator. Looks absolutely excellent. And what that registration route does is it creates a new user inside of the users table with a username and password. So now, once we have a registered user, we can allow them to log in. And the way this is going to work, if we come into the index.html and look at our authenticate function, Here we have the isRegistration code. We're obviously not registering anymore, we're logging in, so we hit this else case where we log in an account. And you can see first it's to the /auth/login route or path. We post information as part of that network request. It's of content type JSON, and we transmit a username and a password over as the body of the request. Now, when that hits our endpoint, the first thing we're going to have to do here is destructure out the username and the password. And the reason we have to do that is because we need to check our database for an existing user that matches that username, and then we need to retrieve the hash password and compare the two of them, see if they are valid. So the first thing we're going to do is, just like we had inside of the registration route, we're going to destructure out the username and the password, where if you haven't picked up on this yet, the username and the email are equivalent. Now they come from the request.body, which is the body of the request, which is the information that is being posted with the network request. Now, whenever we interact with the database, we're going to throw that inside of a try-catch block where we catch the error and we console.log the error.message. So if we do have an error, we can see what it is. And in the case that we get an error, we're going to send a status. We're going to say response.send status, and we're going to send a 503, which indicates that we had an error in the backend. Internal server error. Now the try block is going to contain the logic that is going to attempt to interact with the database. And just because that can potentially be a precarious operation, for example, in the instance where our database is shut down, we need to handle that potential error case. Anyway, so it's time to interact with the database. The first thing we need to do is pull up the existing user. So what we're going to do is define a variable called const, and we're going to get user, and that's equal to database, and we're going to prepare a query that is going to read the database for this user. So we're going to go database.prepare, invoke that method, and in here we're going to have a string. Now the SQL command we need to use to read an entry from the database is we say select, and then we use an asterisk key to say we want to read every single column from the database. So we read everything from the user's database, and now what we're going to do is throw in a condition. So we're going to read in all of the data from users where the username is equal to, and then we're going to have the placeholder. So this is the SQL command. We need to read all of the entries from the user's database, but then actually have a condition that filters out a whole lot of them. So now that we have that query prepared, we can go ahead and run it. So we can assign it to a variable called user, and we can just say get user.get method, and we get the user that matches the username. So essentially what this command does is it's going to inject this username and into this question mark right here, and then it's going to read everything from the users where their username matches the one that we pass in. So that's just an email lookup from a SQL database or a SQLite database. So now that we have this theoretical user, we need to throw in some conditional logic for the case where no user is returned. So if they try login and they don't have an account, we need to reject them out of this process. So what we're going to do is throw in an if clause that says if not user, then what we're going to do is we're going to return out of this function, but we also need to respond to the network request telling them that we couldn't find a user. So we're going to say res.status, we're going to throw in a 404 could not find, and then we're going to send an object that contains the key message and the associated value of user not found. So if we go ahead and save that, we can actually test that. So what I'm going to do is come into our to-do app.rest, and I'm going to restart this code. So I'm going to Control-C, rerun npm run dev, and that is going to reboot our application. And the reason I'm doing that is because that is going to empty our database. Every time we restart our server, it's going to empty out our database. Now if I log in, I would expect us to not find a user. However, since we've handled that case, we should get an appropriate response. And if we send that, we can see that we do in fact get back a 404 that contains that message, user not found. Now, if I were to instead register a user, we get back the token, and now that has created an entry in the database, and I should then be able to log in, and we can see that when I hit the login, it actually doesn't respond. We're just stuck waiting, and that's specifically because we haven't handled the case in which we actually find a user. We haven't responded to it yet. So I'm just going to cancel that, but that confirms everything is working well for the case where we cannot find a user. So if we get past this, what's known as a guard clause, because it guards the code or the successful code in the case where we do have a user, now what we need to do is check that the password is valid. So what we're going to do is define a variable called const password is valid. And what we're going to do is use a bcrypt method. So we're going to type bcrypt, and we're going to compare. We're going to use the compare sync method, which is a synchronous comparing. And we're going to compare the password, which is the one that the user has just entered, with the user.password. So user.password is the second argument to this compare synchronous. And essentially, we can see what the method does right here. It synchronously tests a string against a hash. So essentially what it's going to do is, as I described earlier, it's going to hash our password and compare it to the hashed password. Make sure that they are equivalent. So essentially that's going to return a Boolean where if the password is valid, it's true. If it's not, if it's incorrect, if the comparison is not true, then it's going to return false. Now, because we're in the habit of using guard clauses, we're going to first handle the case where we find that the password is incorrect. So we're going to say if not password is valid. So if the password isn't valid, then we're going to return out of the function, break out of this code, and end the execution. And we're going to respond with a status code of 401, and we're going to send back an object that has a message key that is associated with the string invalid password, and that can be lowercase password. So now, if the password is incorrect, we're going to respond and basically say, nice try, buddy, not getting in today. Now, if we get past this guard clause, then we have a successful authentication. So let me just add in some comments here. So if the password does not match, return out of the function. And up here, this guard clause says if we cannot find a user associated with that username, exit or return out from the function. So now we can handle the case where we've matched the password, we've found the user, and everything looks good. So what do? Well, just like we did above, we sign a token and we send back the token. And I actually think the code is nearly equivalent. So all we do is we give them back the unique token which we associate with their account, which they can use to authenticate all of their CRUD actions and all of their to-do updates. And then whenever they go and make those actions, we can just verify that they are in fact the correct user. So first we have to get the token. We're going to define a variable called const token, and that's going to be equal to, and we're going to use the JWT JSON Web Token library dot sign, the sign method, and this takes an ID like it did just above. Up here we provide the ID of the user, except in this case we access the ID via this little through the result.last inserted row ID. In this case, when we do have a user, we can just access the ID field. Now what I might just do here is actually console.log the user so that we can see what we're actually looking at when we run this request. But anyway, that is the first argument we need to pass into the sign method. After that, once again, we do the process.env, we access the environment variables file, and specifically the JWT secret key. And then we have one last argument, which is an object, and that contains the expires in key, and that just once again expires in 24 hours. So that's going to create this token for us. And then the last thing we do is we send that back. We res.send or res.json if you want to send JSON. And in this case, we just send the token back from our endpoint. And just like that, we have all the logic we need to successfully handle authenticating a user. So now we can actually go ahead and test that. Let's once again restart our code by Control-Cing out of it and then running the npm run dev command. And now we're going to log in a user which won't exist. We get back user not found. Now I'm going to register a user by running this register end client emulation. So now we get back a token. That's super cool. And then we should be able to log in a user. However, I'm going to use the incorrect password. So now we log in. We do in fact get an invalid password. But now if I correct the password, we should receive the token. So that works successfully. And we can see we actually consoled the database entry for that user. So we can see they have an ID of 1, we can see their username, and we can see the associated hashed password. Now, once again, this is the token we're going to use to authenticate all of our to-do CRUD actions. So we'll see how to use that in just a second. But before we do any of that, we have some CRUD endpoints to now set up. So we're going to come across to the to-do routes and start filling out these endpoints. So there's 4 endpoints in here. There's a get for getting all of the users to-dos. There's a post, a put, and a delete. Now these endpoints are relatively straightforward. For example, if we want to get all of the to-dos associated with a user, all we have to do is once again prepare a SQL query. So we type const get to-dos, and that is equal to, we go to our database, which we've imported just up here, and we prepare a SQL query. Now, once again, just like when we're reading from all of the users, we say select, we use the asterisk, which ensures that we select all columns, and we select from the to-dos database. Now, because we only want to get to-dos associated with a particular user, we just throw in a where command and we match the user ID. The user ID has to be equal to the placeholder that we will fill out shortly. So just to summarize how this query works, we say select all the columns from the to-do database where, only where, so it's actually technically not every entry, it's just only where the user ID matches the value we're going to pass in. And now what we can do is we can say const to-dos is equal to, and that's just the query, and in this case we're going to use the all method because we want all of them, and we're just going to access the request.user ID. Now at this point you might say, but James, don't we have to read these values from the body of the request? And that would be one way of doing this. However, the request in this instance is slightly different because of some logic we're going to add to the middleware. So once again, the middleware intercepts the endpoint receiving the network request. So it gets there just first, and it's like a security layer. So what we're going to do is actually finish this endpoint, assuming that our request does in fact have access to the user ID, and that should be a lowercase ID. And then we're going to see how the authentication middleware works. So in the case that we do fetch all the to-dos associated or where a user ID matches the one that we've just got from the request, we can just send back JSON containing the to-dos, which is an object. So that's this endpoint complete, but as I said, we need to complete the middleware, which is going to authenticate a user and make sure that they're the correct person. Now all of that is going to happen inside of our auth middleware, so we'll save this file and head over there. Now the way that this middleware is going to work, we'll once again need the JWT package. So we're going to import JWT from JSON Web Token. Now notice how we've been signing all of these tokens and giving the user all of these tokens. And if you come back to the index.html and look at any of the fetch to-dos, we can see that we then send this to-do as a network request over the internet when a user makes any of the CRUD actions once they're actually logged in. So they're logged in, they have a token that authorizes them, and then that token is attached to every network request they create while managing, reading, updating, deleting all of their to-dos. Now the purpose of the middleware is we intercept that network request and we read in the token and we verify that the token is correct for that particular user. So in here, what we're going to do is define a function called auth middleware, and that is going to receive some arguments. It's going to receive 3 arguments. Now the first one is the request, the second is the response, and the third is a parameter called next, which is new. We haven't seen that yet. The request and the response are pretty standard. The request is going to be super important because we're going to need to access the token associated with that request. And the response is also important because if our middleware, our authentication middleware, intercepts this request and finds that the user is not in fact correct, then we can reject them using this response. So we can basically respond before the endpoint actually receives the information. We'll see what next does very shortly. Anyway, I'm going to go ahead and open up this code. Now in here, the first thing we need to do is define a variable called token, and we're going to read that from the headers of the incoming request. So the way that works is we say const token is equal to the request dot headers field. So we access the headers of the request, which once again, if you remember from when we create the network request from the client, we have the token inside of the headers associated with the authorization key. So I'm going to copy that key because we are going to read authorization from the headers, and that is going to give us access to the token associated with the incoming network request. Now, if we do not have a token, if we try to read the token and there's nothing there, then we can return out of this function and we can respond with res.status. We send back a 401 network request, which basically says the error doesn't have a problem. Actually, your request is problematic. And we send back a message. We're actually going to use the JSON method to send back this message. That's going to be an object, and that's going to have a key message and an associated string that says no token provided. Now that's a good little gar clause, and if we get past that line, that guarantees that the token has been provided, and now we can verify it. So what we do is we use the JWT package and we use a verify method, and this takes a bunch of arguments. The first one is the token, so that's pretty straightforward. We have to verify the token. The second, if you recall, when we signed these tokens, we signed them with a key, the JWT secret key. And once again, this is a highly secure key, and that's why it's in our environment variables.env file. So we're going to go ahead and read in from process.env.jwt_secret. We're going to gain access to that secret key as the second argument. And then the third argument is a callback function. So essentially what this function does is we verify the token, and then we get given some outputs, and this function is run, and it allows us to basically say, in this case, do this. Now this function receives 2 arguments. One is the error, in the case where something goes wrong, we're trying to verify and something goes wrong. And the last one is a parameter called decoded. Now we're going to go ahead and open up this arrow function, and in here, if we get an error, then we're just going to return out of the function once again, and we're going to respond with a status of 401, and we're going to provide some JSON that's going to have an object with the message key, an associated string that says invalid token. So we tried to verify them and it didn't work, and so we're sending back a response saying, nice try, buddy, you're not the right person. Or potentially just that their token has expired, they need to log in again. So that's in the case that we get an error. Now the decoded argument is basically going to give us access to some of the core parameters of the verified user. And what we're going to do is we're going to assign them to the request. So the request, as much as you might think of it as a network request coming in, something we can't change, well, technically, if we intercept it, then we can modify some parameters of it before it actually hits the endpoint. And it works just like an object. So we're going to say request.userID, and that is going to be equal to the decoded ID, which is the ID that we found from that user. And then the last thing we do is we call the next method, and that basically says, okay, now you're good to head to the endpoint. So we've modified the request, and then when we call next, we say you pass this checkpoint, this security checkpoint, you can now reach that endpoint where if they were trying to get to-dos, we can now read the to-dos from the database. And since we've added this user ID parameter to the request, we can then access it from within this this endpoint from this request. Now, the reason we don't just do this process inside of the endpoint is because with middleware, we can write this function once and then slam it in front of every single authentication protected endpoint. Anyway, so now we have this code where we basically verify the token. If we find out that they are indeed the correct person, then we modify the incoming request to ensure that it also contains the ID of the user, since we've verified them, and then we tell them you may carry on to that particular endpoint. So that's the auth middleware complete. Now, how do we actually throw it in front of the endpoints? Well, the first thing we need to do is export a default module called auth middleware. So we have to export it from this file, and then if we come over to our server.javascript and come down to this particular app.use to-dos endpoint, all we do right here is we literally slam it in front of our to-do routes. So in this case, we would just throw our auth middleware, which I'm using the auto imports right here. We can see it's suggesting I import it. And I'm going to throw it in between the to-do routes. So we can kind of think of it as like, okay, we hit this endpoint. First, we encounter the middleware. And then every single to-do route endpoint is blocked by this middleware. And that is imported just here. And that is now available. And if I go ahead and save that, that should make sure that all of our to-do routes are protected by our auth middleware. Well, we have to confirm the token. Now, two small things I wanted to clarify really quickly. First is regarding the inside the auth middleware, specifically what this next does. This next just says, okay, you may now proceed to the endpoint. So it's the final step before saying, okay, we're done with the middleware. Let's go on to the actual endpoint, which is one of these to-do routes. And that is, all of them here. So we hit the auth middleware. We call that next in the case where it's an actual verified user. And then we send it through to the to-do routes, having added the ID to the request so that within the to-do routes, we can read the ID from the request. Now, as for the decoded ID, if you recall, when we originally create these tokens, when either we register or we log in, we actually create the token encoding the ID. So the ID is what we associate with the user. And so when we encode it into the token, we can then decode it. And that's what this decoded is. And consequently, we can get out the ID and verify the user. So those were just two small clarifications I wanted to make. Now, we're actually at a super cool point in our project because what we'll do eventually is come down and write the client emulations for all of these endpoints. But we can actually register a user, log in a user, and fetch all of our to-dos, which for a brand new user should just be that one default entry that we added when they register. So they get this default to-do, everyone who signs up to our app. And the front end should be able to fetch all of those things because we've created the complementary backend endpoints to facilitate that interaction. So what I'm going to do is once again restart my server completely. That's going to clean out our database, and then I can now attempt to log in. Let's try a random user. I go ahead and sign in. It says failed to authenticate. That makes sense because we don't actually have that user saved in the database. If I right click and come over to the in Chrome Developer Tools by clicking inspect, we should be able to take a look at that network request right here. So if I refresh that page and we do that once more, we'll go for test@gmail.com. I'll do the favorite password and submit that. We can see we send out that endpoint, we get a 404 not found. We can see here's the payload that got sent out as part of the network request from the client, and then the backend received it, and then we responded with the JSON that said user not found. So that all works perfectly. However, now if I try to sign up, I can submit that, and we can see it's actually logged us in. And we can see a few extra network requests were just run. One was this register endpoint, and we can see we got back a 200 OK. We can see it was to the auth/register endpoint, and we can see we sent over the username and password, and we got back a response containing the token. Now, the way registration is working in this application is that it also, upon successful registration, logs in a user. If we take a look at the front-end code and come up to the authenticate function, basically the registration and the login functionalities both serve to gain access to a token. And then once we have this token, if the data contains this token, we save it, we cache it, essentially in cookies or local storage, and then we load all the to-dos by calling this fetch to-dos method, which if we come down, sends out a network request saying, okay, now we have access to this token. Let's send it to the /todos endpoint. It's a GET request. We get all of the to-dos back. The endpoint responds with the to-dos. It looks them up in the database once our middleware has authenticated the user via this token. And then when we get the to-dos back, we display them on the screen. We render the to-dos. And consequently, we end up with a dashboard right here. And that's what it looks like. It's nice and responsive, mobile responsive, looks great. And we have our first to-do right here. Now currently, once again, we can't add to-dos, we can't edit to-dos, we can't delete to-dos because we haven't finished those endpoints. For example, if I try say done, we just get a failed network request. We don't get anything back, nothing happens. If we delete, we also just get absolutely nothing back. It's not working. So we're going to have to program them in a second. But we can now log in, display a dashboard, register a user, log in a user, and our token is working. And we can confirm that by reloading this page. If I reload this page, we can see it asks us to log in again. And now if I go test.gmail.com, type in our password and submit, we can authenticate once again, and now we have this token. Now, as for the token, we can come across to our application right here, and we can see that inside of local storage, we have our token saved right there. So that is all hunky-dory, and that's working brilliantly. So now what I'm going to do is start to code out the rest of these endpoints. So the first one we have to code out now is this endpoint that allows us to create a new to-do. Now the way that this one is going to work is not too dissimilar to this first endpoint, but it is a great opportunity for us to learn some more SQL queries, which is kind of fun, because at the end of the day, we're writing these SQL queries to inject the data into our database tables. So what I'm going to do is once again log in. We submit that. That is done. We're now in the dashboard to add all of our information. So if we first come into our index.html, let's find the function for adding a to-do. So just here, we can see the network request from the client that tells our backend endpoint to add this new to-do to the database. So we send out a network request. It's a post method, which is typically for the creation of something. And we post information. We send information across with this network request to the to-dos endpoint. We include the content type. We say that it's JSON information that we're encoding, and we authorize this request with the token so that our middleware can confirm we are the correct user. And then finally, we send over the task, which is whatever is input into this field right here when we click this button. So our backend can expect to receive the task as part of the body of the request. So if we come into our post request right here for creating a new to-do, the first thing we can do is we can define a variable, or better said, we can destructure out the task from the request.body. Once we have access to that task, what we can do in here is we can define the SQL query. So we can say const insert to do, and that is equal to database.prepare, and we can now prepare the SQL query. So we're going to use the backticks, and then in here we're going to say insert into, then we'll specify the table, which is the to-dos table, and then we're going to provide the columns for which we have information, which is going to be the user ID underscore ID and the task column. The user ID is going to specify what user our task should be associated with, and that is going to be something that we can now access from within the request because of our middleware authenticating our user. So once we specify the columns, then we provide the values, and those are just going to be 2 empty question marks as placeholders until we complete the query. So now that we've prepared the query, we can go ahead and insert todo.run. We can run the query, and we can pass in the request.user ID as the ID for the user that we want to associate the task with. And then we can also pass in the task itself, and that is going to insert that to-do into our database inside of the to-dos table. Now, once we've inserted that to-do, the last thing we need to do is res.json. We need to respond. So we're going to use the res.json method, and in here we're going to provide 2 key value pairs. The first one is going to be the ID of the to-do, which we can access by going to the insert to-do, and we can get the last ID. That's going to give us access to the ID of the most recently added entry. And then once we have that, we can now also send back the task, and we can send back the completed status of 0 because it's false for the minute. The 0 represents the false Boolean state, and that's because our to-do is not yet done. We've literally just added it. So we can now save that endpoint. Now what I want to do at this point is just actually create the client emulations for both of these actions. So the first one, so obviously we've got 3 so far. One is to get the home page. We've got a register a user and log in a user. Now we need to emulate the fetch all to-dos endpoint, which is going to be a get to the slash to-dos endpoint, a get request to the slash to-dos route or path, better said. And I might also make a note that this one is protected. And essentially how this is going to work is we very simply have a get request to http://localhost 5003 or whatever port you're using slash to-dos. Now first what I actually want to do, since this is a get request, we don't need to provide any information as part of that request. We can just send it. But in its current state, I haven't provided the token to associate us with a user. So if I just run this request, we would expect to be blocked because our middleware can't authenticate us. So if I go ahead and run that, I get back a 401 which says that I'm unauthorized, and we get the message saying no token provided. Now the way that from this REST client we provide an authorization token is very simply by writing authorization and then a semicolon, and then in here we put the token. Now for the minute we don't have a token, so what I'm going to do is register a user. That's going to create a user with these credentials, and then I'm going to copy the token right here, and that's the token we're going to use for authorizing these to-do CRUD actions. So now that I've pasted in the token, I should be able to send this request, except the difference is this time when we send out the request, we have encoded the authorization token into that request so that our middleware, our auth middleware, can intercept that and interpret it and consequently authorize us. So now when I send that out, we can see that I do in fact get back a to-do entry. It has an ID. It's the very first to-do. We can see that it's associated with a user with the ID number 1. So that's our first added user. And here we can see we have the task, and here we can see we have a completed status, which is 0, which is the false Boolean status. So that is an incomplete to-do. Now what I want to do is define a client emulation that creates a new to-do, and that is a post to the /todos endpoint, and that is also protected. Now that is going to be a post to the http://localhost 5003/todos. Now this one has a bit more information. First up, we once again need to authorize the user, so we're going to copy and paste that token. Now one thing to note is that if you're restarting your user, that token will be invalid as our database refreshes every time we reboot our server. Now that might seem counterintuitive, but in the 4th project we will learn how we can persist that information as we create a third-party database entry. But for now, the moral of the story is that this token is only relevant for either one login session or one registration session while that user is persisted. So we use the same token. Now what we need is also some JSON that contains a task. So we're going to add the task field right here, and also have an associated string that says finish coding the projects. Now, as always, because we're including JSON, we have to add the content type header to this request by specifying the content-type, and that's going to be application/JSON. So now when I save that, we should be able to create this new entry because we have also created that endpoint. So I'm going to go ahead and send that request, and we can see that we get back our client endpoint responds with the task and the completed status of 0. Now, one thing I noticed is that we should have gotten back an ID as part of that field. And I think what we're missing just here is we have to create a variable here that's called const result. And instead of just running this command, we actually have to assign the output to a variable called result. And then this should actually be result.last insert row ID. So now what I'm going to do is once again go ahead and run that. And let's try that once more. So if I come back to the client emulator, we're going to have to run all of that again because our server has been restarting. So we will, well actually let's try login. Yeah, user not found. So let's register a user. We get the key. We're going to have to replace the key in all of these emulations. So these authorization tokens are going to have to change to the new token. And now I should be able to test them both. So let's get all the to-dos. We can see we have one to-do just there. That's the default entry when we register a new user. Now we create a to-do, and here we can see we get back the ID this time. So that has worked. And it's important that we get back the ID because in these emulations, when we start specifying what to-do we actually want to modify or delete, we'll do that by specifying the ID of the to-do to, perform these actions to. Now, if I go ahead and get them again, I would expect to have two tasks inside of my database, and indeed I do. I have the default one, and I also have the secondary one right here that we just added. So that is super cool. Now we can go on to the put entry. Now for the put entry, what I'm actually going to do is start off by creating the client emulation for that so we can understand how these dynamic query parameters actually work. So we've now added two to-dos, so we can go ahead and modify one of the added to-dos. So in here we're going to create a new client emulation, and that's going to be called update a to-do, and this is to the how did I specify it? It's post to /to-do, so this one is put, if I can spell that correctly, put to /to-dos, and then it's /an ID, which is a dynamic parameter, so we throw in front the pound key. And this is also a protected route. And when I say ID, this is just a demonstration. There are 100 different update or modification actions you could make. For example, you could change what the to-do entry actually says, but in this case, it's just modifying the completed field. So when we click the completed button or done button just here, that counts as a modification. So that's what we're going to use to demonstrate this kind of endpoint. So that is a put to the http://localhost 5003/todos endpoint. However, if we come to the actual endpoint, we can see that now, where these ones were just slash, so we can't just do /todos, it now has to be /todos/ an ID entry. So since we, saw earlier when we sent out these requests, we have an ID of 1 for the first to do and an ID of 2 for the second request because they automatically increment. So I'm going to go ahead and modify the second to do entry. So in here, what we're going to do is specify the second entry. So we're going to add the /2 on the end, which is this /ID. That's the ID of the to-do that we want to modify. Now we'll still need the content type of application/JSON because we're sending data. And we're also going to need the authorization token. So we'll copy that from just there. And now what I'm going to do is specify the JSON data and tell it that we want to change the completed field to a value of 1. Currently it's 0, we want it to be 1. So that should go ahead and complete that to do. And what you could actually do, since we're running all these modifications, is you could also specify the task and change the data associated with that task, but we're not going to do that. We're just going to modify its completed status. So if I save that, I should now be able to run that and update that entry. So I go ahead and run that, and we can see that nothing happens, and that's because we haven't actually coded out that endpoint. But the moral of the story is you can see just here how these dynamic paths actually work. So just here, we can now, from within our to-do routes, figure out what this ID is associated with. So the first thing we're going to do in here is we're going to access the completed status from the request.body. So we're going to destructure out completed from the body of the request. Now the second thing we're going to need to do is access the ID. Now the way that we get the ID from the URL is we say const and we destructure out the ID from the request.params. So that's the parameters of the request, of which the ID is now 1. Now you can also get parameters from the queries of the request, and that's just specific to the URLs, and we're actually not going to worry about that in this course. But it's just a demonstration of the different ways that we can send information via a network request. We can either send it per the body, or we can throw it into the actual URL. What the last example would look like is just to show you quickly. Let's say here we had a question mark that said task is equal to, and this is the updated text or something. What we could do is if we went request.queries, we could access the task field where the queries come after a question mark. A common example is page is equal to 4. That's a query that's associated with the request, and then you can access the page number and you can consequently get the value associated with that, but we're not going to worry about that. Well, actually, why don't I just show you? Page is equal to 4. Now if I go ahead and run that, once again, that's going to have the exact same output, which in this case is to wait. So that determines that this URL still hits the exact same endpoint. However, now what we would do is inside of the to-do routes to access the page, I would say const and destructure the page out from the request.query. So now we have collectively demonstrated the 3 different ways that, should you want to, you can send information or parameters across via a network request, from the body, via the parameters, or as a query entry. Once again, this last one is not really relevant to this course, it's just good to be aware of, and it's not really going to change anything. You can just throw these queries onto the end of the rest of the URL. So we have access to the ID, and we have access to the new completed status. So what we can do in here is we can now say const updated to do is equal to and prepare our SQL query. So that's database.prepare, and the query here, now we already have an entry inside the database. So we're not going to use the insert to create a new one. We're going to update an existing one. And the way that that works is we say update to-dos, we update the to-dos table, and we set the completed field equal to question mark. Now, if we wanted to update the task as well, what you would do is you would just say task is equal to question mark, and you would comma separate them. So if you wanted to, have two different columns being modified, you just throw them after the set key and you just comma separate them. This is obviously the common name, and this is the new value where the question mark is a placeholder for the data that we will add in a second. But in this case, we're just going to modify the completed status. So we're going to remove that. And now we only want to set these new values where the ID is equal to a placeholder, which is going to be this ID just up here, the ID associated with that to do. So now that we have that SQL command prepared, we can say const result is equal to, well, actually, we don't need the result in this case because we don't have to send back an ID. We can just say updated to do dot run. And in this case, we pass in the new completed status, which we destructured. And we also pass in the second question mark, which is the ID. And that's the ID that we gained from the parameters, which is part of the URL. Once we've successfully updated that, we can just send back res.json, and we can send back an object with the key message and the associated string to do completed. So now if I go ahead and save that, we should be able to run all of these emulations. So first we have to register a user. That gives us the token. We'll copy the token and we'll paste it inside of the CRUD actions. So first what we're going to do is just get all of them. So that's our default entry. It's currently got a completed status of 0. Now we're going to change the authorization token for adding a new entry. We're going to add this new entry right here. That is now added. We get back its ID of 2. It is also incomplete. And now we have one for updating, and that is going to update the to-do with the ID of 2. That's the dynamic parameter. And this is the query on the end that, as I said earlier, anything after the question mark isn't going to change the actual endpoint we hit. It's just specifying some further unimportant information in this case that's not relevant. It was just to demonstrate a point. The 3 different ways we can encode information into a network request, via the body, or via a parameter, or as a query. Anyway, so this hits the update endpoint. Have we updated the token? Let's just confirm, Control V. No, now it is updated. So we can go ahead and update this, and this should change the completed status of the to-do with the ID of 2 to now complete. That is now completed. We get that successful response. It's a 200 level status code, so that is perfect. And now if I get them, we can see that the first entry is still incomplete, but the second entry is now complete. And even cooler, if I refresh the page and log in, what are the credentials that we're logging in with? Gilgamesh@gmail.com. And we type in the password. This should still work because they're both using the same server and database. We can see that we actually have 2 entries just here. And because one is actually complete, we can no longer click that complete button. And it is inside of the complete column. And we now have only one open to do. And now if I go ahead and click done on this particular entry, we can see that that network request is sent across just here. We get back a 200 level status code, and our application changes. So it is now 2 complete entries and 0 open entries. So everything is working perfectly. And so now that that's all done, we have but left one more endpoint, and that is the delete endpoint. Now what I'm going to do for the delete endpoint is once again create the emulation first. Now in this case, what I'm going to do is actually just copy and paste this update one because it's very similar. And this one is just going to be delete a to-do. There's going to be a delete method. And I think that should just be lowercase for consistency. And in this case, because we're modifying a particular to-do, in this case deleting it, we need the secondary dynamic ID parameter. Now we don't need the query in this case, we're just going to have the ID. We still have the same authorization token, and now we actually don't need to send any information, but we do have to update the method to delete, and that is the emulation all done. Now one thing I would like to point out, and this is just, FYI for your information, is that if you're working in a big organization, typically what we're doing right now, which is known as a hard delete, is almost not recommended because it's permanently erased. You can't necessarily get it back very easily. So what a lot of companies will do, let's say you're managing lots of Google Docs, for example. If we came over to where we create this database, typically they will create an additional field inside the relevant table called soft delete. And that's once again just a Boolean value where when a user deletes it, you actually don't remove the entry from the database. You just change the soft delete value to true. And that way it can be restored at a later date. So it's kind of just like a fake delete. That's just something interesting to be aware of. We're not necessarily going to handle that in this case. We're going to go for a perma delete. But I just thought I'd mention that. Anywho, so now that we have this emulation going, let's go ahead and fill out this last endpoint and wrap this project up so that we can dive into the more advanced version. So this endpoint is once again relatively straightforward. It's going to delete a to-do, and the first thing we need is to access the ID. So we're going to destructure the ID by saying const ID is equal to the request.params, because it's a parameter. This is a dynamic parameter. So that's going to give us access to the ID. Then we're just going to prepare the SQL query. So that's going to be const delete to do, and that is equal to database.prepare. Now the SQL command to delete an entry is as follows. We're going to delete from, then we specify the table, which is the to-dos table, and then all we have to do is say, provide the condition essentially. So we say delete from the to-dos where the ID is equal to a placeholder that we'll fill out and a Boolean operator. So both of these have to evaluate to true for it to be deleted, and the user ID is equal to a question mark. Now the reason we're having a Boolean condition here is because we want to match both the to-do ID in addition with the user ID. So that's just basically a double security to ensure that we're only deleting a to-do that is associated with the correct user. So now that we have prepared the query, we can go ahead and run it by saying delete to-do dot run, and then we just pass in the ID as the first field and then the user ID as the second field, and we need to get access to the user ID. So we can just go ahead and destructure out the user ID from the request. That would be one way to do it. Or we could literally define a variable called user ID and set that equal to request.userid. So that's going to gain us access to the user ID. These values are going to be injected into this query and consequently run, and that should complete our endpoint. So now if I go ahead and save that, it's going to refresh our database, and let's run through this from the very beginning. I'm also going to refresh our app, and the other thing I'm also going to do is just delete the token in here and refresh the app. So now that we also have a blank application. So first up, let's test the emulator. Well, first what we're going to do is we're going to register a user. That works perfectly. And now that we have registered a user, I can go ahead and log in the user to confirm that that's working. So now we log in a user, we can see the user just down here. There's the hash password, and we can copy this token. Now that we have the token, we can run all of these authentication protected endpoints. So first I'm just going to change the token in all of them, and then we'll go and have a fiddle. So first what we want to do is we want to fetch all the to-dos. We just get the default one, that's perfect. Now we're going to go ahead and create a to-do that adds a new to-do. And I'm actually going to create that twice. So now we have an ID of 3. And if I get them all again, we can see that I do in fact have 3 to-do entries. Now I'm going to go ahead and run the put, which is a modification, and that essentially enacts to complete a to-do. So if I run that, that should complete the to-do with the ID of 2, so this middle one. So we run that and the to-do is now complete. And if I go ahead and get them all again, we can see that the to-do with the ID of 2 is in fact complete. This one state represents true. It's kind of like binary. And then what we can now do with our last endpoint is delete the entry with the 2 since we've completed it. And that didn't work, and that's because we forgot to respond. I actually think in the context of our database that will have run, because technically we will have hit the endpoint and run the logic. So if I go ahead and fetch all the to-dos, we'll see that the element or the entry is missing. But yeah, we just need to respond inside of the to-do endpoint. So that's the last line that I totally forgot. So in here, we'll just say res.send, and we'll send a message that says to-do deleted. Very simple. And just like that, we have officially completed project number 2 and chapter number 3. We now have a fully functional application. If I once again come over to the dashboard and try sign in with Gilgamesh, run our password, that fails. So I'm going to sign up. I can now submit my sign up. We add that default entry to the database. I can say that we've done it, even though technically we haven't. That changes the tab that it's available in. I can add a new to-do. Let's say go to the gym. Add that. That gets put in here. I can refresh the page. Those are fetched back for us. I can say I've done that now. That is in the complete tab. We have no open to-do, so I can add one. It says hello. That is now added. And I could go ahead and delete that other entry. And then if I refresh the page, everything is persisted and our project is complete. So that is absolutely brilliant. Massive congratulations. Once again, if you do want to support the channel, be sure to star the repo. Love that support. And with that project complete, it is now time to dive into chapter 4, our final project, where we're going to take this code base to the absolute moon. Alrighty, welcome to chapter 4 of this full course, where we're going to take our backend programming skills to the absolute moon by building out the ultimate backend application. Now, in this particular project, we're not going to start the same as we have started the rest of the projects, where historically we've run that npm init-y command and we've built our project up from there, installing all of the modules from the npm ecosystem and creating all the files and folders. Instead, this chapter 4, project number 3, is actually going to be an evolution of chapter 3. Chapter 3 is like the beginner version of developing a complete backend application, and chapter 4 is going to be like what you would find in a company or massive tech organization, enterprise level, absolute god tier backend infrastructure. As for what exactly is being evolved, well, there's 2 things, actually 3 things, I guess, in particular that are going to change and upgrade from our previous project. Number 1 is the database. In the previous project, we used SQLite, which is a brilliant database, but if you're going to build a big production level application, then you'll want to go with a more reputable SQL database such as MySQL, or in this case, PostgreSQL. PostgreSQL is my all-time favorite SQL database, and in this project, we're going to put it to good use. The second core difference between chapter 3 and chapter 4 is that in this project, we are no longer going to be writing out these custom SQL queries. Instead, we're going to use what is known as an ORM, or an ORM, or an object relational mapper. And what this does is it's like a middleman between our Postgres database and our JavaScript, where we can now interact with our database, our SQL database, as if it were a JavaScript entity. And that is thanks to our ORM, the middleman. And in this case, we're going to be using an ORM called Prisma. It's very popular. We're going to learn how we can integrate it into our project with Postgres. And we're also going to learn about all the other advantages that come with using an ORM, because there are many. And last but absolutely not least is that we're going to Dockerize our entire project. Now in chapter 3, we actually had our database and our server as essentially the same entity. And this project is going to be different. They're going to be two separate environments. That means that our server is going to have to communicate to an external database, and both of these are going to be their own independent Docker environments. Now this is a much better practice, because if your server breaks down, it doesn't mean that your database has to completely restart itself, and it also means that our database is going to be able to persist data that much more effectively. So at the end of the day, these are some absolutely massive changes, and there's also going to be a whole lot of other stuff that we will learn as a product of making these evolutionary changes. So it should be loads of fun. Now, as for how we're going to kick this project off, it's not going to be like the previous chapters either, where we have previously run npm init-y and then installed all the packages from the npm ecosystem and then built up our file directory from there. In chapter 4, what we're actually going to do is create a duplicate of chapter 3 by right-clicking, hitting copy, and then we're just going to paste that folder directory, and we're going to end up with a duplicate that we can then rename, and we can turn it into chapter 4. So now we have our code base that we can go and rip to pieces, keep the core logic, keep the server, and make any necessary changes so that we can create this evolved backend project. Now the first thing I'm going to do inside of here is come into our package.json, because I'm just going to change the name of our project, and I'm also going to change the description just here. So this is instead going to be a Dockerized full stack application that uses Node.js backend, a Postgres SQL database, a Prisma ORM, and JWT Authentication. So those are going to be the core changes made in this project. Now as for what we're going to start off with, we're going to install the necessary packages that we need for these new technologies that we'll be using in this project. Specifically, we're going to need to npm install, number 1 is Prisma, number 2, we can space separate different ones, is Prisma/client, and number 3 is a package called PG, and we'll learn what that does later. But essentially it's just a client for Postgres. So if we hit enter, that's going to install those packages. And I realize I'm a muppet, we actually need to first change directory into our new project. So I'm just going to cd into chapter_4 and then run that command once again. And that will install them all. And now we can see inside of our package.json, we have our Prisma client, we have PG, and we have Prisma. Now the second thing I'm going to do, and this is where we're going to start off making these modifications, is we're first going to create this Prisma client. And the way that we kick that off is we start by typing in a command, npx prisma init. And if we hit enter on that, that is going to create a Prisma folder inside of our chapter 4 project directory. Now inside of this Prisma folder directory, we can see there's a file called schema.prisma. Now if you're unfamiliar with what a schema does, it basically is a folder that specifies the structure of our database. So if we think about chapter 3, when we created this database.js file, we specified what we wanted our tables to look like inside of our SQL database. Well, the schema does it in a similar way, where instead of using a SQL command, we create it as if it were a slightly complicated object. And that's because it's going to allow us to interact with it as if it were some form of object. And that's just going to ensure that our code stays much, much cleaner. So we're going to open up the schema.prisma, and there's about 15 lines in here, and we can just leave them all in there. Now, there might be a couple of lines in this file that are a bit confusing, but we'll only add about 14 lines. If you want to learn more, you can check out the docs at this particular link, and it will explain everything you need to do, but you'll also learn by doing in this particular case. So when we create this conversion between our SQL database and JavaScript, we essentially need to create a model for our JavaScript to allow it to interpret these SQL tables. So in this case, we're going to need two models. So we say model, and then we define the name of the model, which is the user. And this is essentially going to be the structure of the model. It's kind of like predefining what the tables are actually going to look like. So we're going to create this user object, and in here, what we're going to do is just like we did before, we're going to create the columns that are going to exist inside of that table. So the first one is going to be an ID, as we had before. Then I'm going to tab across and specify that it's of integer type. And then I'm going to tab again, and in this case, we're going to have some extra parameters. So the @ID is going to have an @default, and that's going to auto increment, and we're going to call that. So this just here basically says that, this is going to be a default parameter, which means that we don't need to specify it when we create a new user, and we want it to auto increment as we add new users. Now the second field in here is going to be the username, and that is going to be of type string. And in here, we're just going to ensure that that is unique because we can't have two users with the same name. Underneath that, we have a password column, and that is going to be also a string, and there's nothing special there. And last, we have the to-dos, and this creates the relation between the two tables. And this is just going to be a to-do as an array. So that's going to be our user model that we're going to use to basically interact with our PostgreSQL database using a JavaScript syntax. Now we're going to define our second model, which is going to be the to-do. This is what our to-do is going to look like. And once again, we're almost done with this file, but if you want to learn more about it, all of the information is in this docs. For this project, once we create this schema, then we just initialize our database using this schema, and we're good to go. So for the to-do, the first parameter is going to be an ID, pretty similar. This one is going to have of type integer, and it's also going to be @ID @default auto increment. So that's pretty straightforward. The second field for the to-do, as per the Chapter 3 project, was the task, and that is of type string. Underneath that, we have a completed status, and that is of type Boolean. And in here, that's going to have a default @default of false, because when we add a new to-do, it probably hasn't been completed yet. Underneath that, we're going to have a user ID, so that's going to associate the task with a particular user. That's going to be an integer field. And finally, we're going to associate this table with the users table. So we're going to have the user, and that's of type user, and in here that's going to be a relation. So we're going to type @relation, and we're going to have the fields, and in here we're going to have a user ID inside of the square parentheses, and then we're going to create the references, and that's going to be exactly the same, just like that. And this is the schema we need for our entire database. We can see up here it's already configured for a PostgreSQL database, and we have the client. So this right here is the code we need to configure our PostgreSQL database for a user, or the table specifically, and here we have another table, a predefined template for our to-do table. So we can go ahead and save that schema. Now, one of the reasons why an ORM is also absolutely brilliant is because of a concept known as migrations. With our previous project, if we were to deploy this live to the internet, we create these tables. Suddenly, if we're in a production environment and we need to change what our database looks like, that's going to be incredibly complicated. How do we go back through and make these modifications to all of the entries inside of our database? Like if you have 100 users that are using a primitive form of your database and then 100 that are using a later version, essentially version control of your database becomes incredibly complicated when you have loads of users relying on a daily basis. Using something like an ORM allows you to easily introduce the concept of a migration. So essentially what it is it's just a record of all of the modifications that have been made to the database, and when you run your migrations, every instance of your database is updated to reflect these changes. So it's always the most recent version, and it's also, it supports these legacy entries. So all of the previous entities have been updated to reflect these changes. So essentially what's going to happen is eventually when we create our Postgres environment, our PostgreSQL database, we will run our very first migration, and it will format our database to match this schema. But we'll see how that works in a second. I know that can be a little bit confusing. Now, the other file we'll need for our database is a Prisma client, and I'm going to create that inside of the source directory. So we're going to create a new file called the Prisma client.js. Now, this file is pretty equivalent to the database without all this funny business down below. We're just going to create an entity, a Prisma entity, through which we can interface with our PostgreSQL database. So in here, what we're going to do is import the Prisma client from at Prisma client. Pretty straightforward. Then we initialize it. We say const Prisma is equal to new Prisma client, and we invoke that. We instantiate that class, and then finally we export default Prisma so that we can access this Prisma entity from anywhere inside of our project. That's that file totally complete, and now that we have it, we can go ahead and see how radically improved writing and interacting with our database can actually be. So the database interactions that we're going to be modifying are within these auth routes and these to-do routes, and I'm going to start off with the auth routes. So just up here, we can see this is the code that we used to do to create a new entity inside of our user table, and then likewise with the to-dos tables, where we prepare the SQL query and then we execute them. Well, once again with Prisma, it's a little bit different. So what I'm going to do is start off by deleting this insert user query, and instead I'm going to say const user is equal to, and I'm going to await, because now that our database is a third-party entry, the communication between the server and the database is an asynchronous process. So we have to make sure that our endpoints are asynchronous. So now what we do is we await Prisma.user, we access the user model that we have created, and all we do here is we call the create method, and we pass in an object. The object has a data field, and that is an object itself. And in here we provide the username and the password, which is the hashed password. And just like that, we have created a user using a JavaScript syntax. So that is super easy. Now the second thing we have to do is insert a to-do. I can get rid of all these SQL entries, and now I can just await prisma.todo.create, pass in an object as an argument, and in here we have a data field that's also an object, and we just have the task, which is the default to-do, and we have a user ID field, which is the user.id. It's super simple. This user right here is just what gets returned. It's essentially just that model object that we created inside of the schema. And that's all we need to do. Well, actually, there's one more thing. Now we just take this user to do and replace this code just down here. And we have now updated this file to instead use the ORM, Prisma, instead of having to manually write out all of these SQL queries. So that is the registration done. Let's see what it looks like for the login. Well, for the login, we can get rid of these two lines right here, and we can say const user is equal to, we await. Since we're having to await, we need to make this endpoint asynchronous, so we just throw an async in front of that function. And then we just await Prisma, the user entity, and we find a unique entry that takes an object. And in here we specify a where clause. So it's kind of like the SQL logic where we say where ID is equal to ID, or in this case, where username matches the username that we have entered just here. And that is literally all the code we need to find our unique user. So I can now save that file, and that is complete. Now we're not quite ready to boot up our project just yet because we haven't actually instantiated our Postgres Docker environment just yet, but we will get to that very shortly. First, we're just going to update some of these to-do endpoints so that we can finish up with our Prisma ORM configuration. So first, let's get all the to-dos. So we're just going to remove this code right here, and we're just going to say const to-dos is equal to, we're going to await, we're going to import Prisma, which we also had to make sure we did inside of this file, and I actually didn't do that, so that's me being naughty. Let's make sure we import Prisma from our Prisma client, save that, make sure it's imported inside of our to-do routes as well, and then we can await Prisma. We access the to-do table and we find many because we're getting a lot of them. And in here we provide an object and we just say where, and we want to return the entries where the user ID matches the request.user ID. Now, once again, this needs to be changed to an asynchronous endpoint, and that is all we need to do to access all of the to-dos where the user ID matches the ID present in the request. Super straightforward. Once again, you can find the documentation for all of these methods at that link inside of the Prisma client, but we're going to demonstrate how most of it works inside of these endpoints. For creating a new to-do, you might be starting to get the hang of this now. All we're going to do is throw in an async key right just in front of that endpoint function. And now I'm just going to say const to-do is equal to and await prisma.todo.create. And in here, that's an object and it takes a data field. That's also an object. And we just provide the task and the user ID, which is the request.user ID. Super simple. And then we just return the to-do. So we're going to actually just send back the to-do. We don't even have to create all of these fields. It's just manually assigned to this variable, and we will get an object that represents this new to-do. For the put entry, once again, super straightforward. We can get rid of all of this logic, and I'm also just going to get rid of this query as well. And in here, we just say const updated to-do is equal to. This one also needs to be made asynchronous. So we throw the async key in there. I'm also just going to throw that in front of the delete one while we're down here, so I don't forget to do it. And then we just say equal to, we await prisma.todo.update, and that just takes an object, and we say where, that's also an object, and we say where the ID is equal to, and we're going to pass integer, so we're going to convert it to a numeric value, and we're going to access the ID, that's the field right there, and then after that we're also going to match the user ID with the request.user ID field. So that's going to make sure we update to-dos only where the to-do ID matches, and also we have the correct user. And then underneath that, we just provide the new data, which is just going to be the new completed field. Super straightforward. And I think in this case, the completed field is currently going to come through as a numeric value. So what I'm going to do is throw a double exclamation mark in front of it, and that is going to convert it to a Boolean amount. And then once again, we can now just send back the updated to-do. Done and done. Super simple. So this command, just to summarize, we update the to-do where all of the IDs match to confirm it's the correct to-do we want to update, and we provide the new data, and we force our completed field to become a Boolean value by throwing the double exclamation in front of it. That's a little secret hack. It'll convert anything to its truthy or falsy state. And finally, we have the delete field. Once again, pretty straightforward. We get access to the user ID, and in here we just await prisma.todo, and we use the delete method that takes an object, and we just specify where, and that is exactly the same as this where clause up here. So I'm just going to pass that in. and we are done. That's literally all it takes to use the Prisma ORM. Super straightforward, and I actually think I can do that, and that will use that value instead. So it's just so much tidier than having all these SQL commands all throughout your files. And just like that, we have configured all of our endpoints to use the Prisma ORM and also to be relevant for Postgres, which is super important. So now that we've done that, we are now ready to Dockerize our environments and actually get our PostgreSQL database up and running. And then the last thing we'll do is we'll see how we can create a compose.yaml file, which essentially just configures everything so we can boot it all up in one command. All right, it is now time to get our hands dirty with Docker and containerize some of our infrastructure. So the first thing we're going to need to do is actually boot up the Docker desktop on our device. If you recall, we installed it earlier, and the link to install Docker is available in the description down below, so you can just come over to that link and hit download Docker desktop and select your operating system. Now when you have it open, it should look something like this particular screen here, where all of our environments are referred to as containers. We contain our application. It's like its own mini environment where we can configure how to set it up and consequently what code to run. Now everything else is going to be done from the terminal, from the command line, so we can just move that to the side. We don't necessarily need it open, but we have to have the application running, and there will be some advantages to having the client open later. Now the way that we go about containerizing our environments is by creating a Docker file. Now the Docker file is basically just an instruction sheet on how we can create this environment so that it has everything it needs to run our little, infrastructure, backend infrastructure, be that the database or our NodeJS server. So what I'm going to do inside of chapter 4 is create a new file, and it's just going to be Docker file, just like that. It doesn't even have a file extension. Now inside here, as I said a second ago, it's pretty much an instruction sheet. And the first instruction we need, obviously we're running a Node.js application, so we need to set up this environment to have access to Node.js. So what we're going to do, I'm going to leave a comment just to walk us through these steps. I'm going to say use an official Node.js runtime as a parent image. Now I remember when I first came across this term image, I was just thinking, oh, it's like a picture. And that's kind of true, but in this context, an image is actually more like a snapshot. It's a snapshot of a separate instruction sheet. So when we eventually create this Docker file and build our container, what is happening is we're creating a snapshot of that environment, and then whenever we run our containers, we can just run that snapshot and get us right back to where we were. And we can build off pre-existing images. In this case, we're going to build off the Node.js official image, and that's just going to take a snapshot of the Node environment that we specify and add it to our new environment that we're creating via this Docker file. So we're just going to use the command from, and we're going to say node version 22-alpine. So that is the official Node.js image we need to throw into our new containerized environment. Now this Docker file just here is specifically for our Node.js application. We'll see how we can get our PostgreSQL environment up and running very shortly. So the second line we need is to now set the working directory. So we're creating this new environment. We need to specify a folder for our project. So we're going to set the working directory in the container. And we do that using the workdir command. And we're just going to say /app. That's where our working directory is going to be. Step 3, now that we've got that Node.js base image and we've got our working directory, we need to copy the files from our local project into this new environment. Because basically it's like you're setting up a new computer. You need to copy all your stuff across. So we're just going to copy the package.json and the package-lock.json files to the container. And the command that we use to copy stuff from our local device into our Docker container is the copy command. And the files we're going to copy first is going to be the package.json files. So we're going to specify that we want to copy any file that has a package in it. So then we're going to use the little asterisk so that it selects both the package-lock and the package.json. And then we just want them to be the .json file. So that is from the source. And then the destination we want to copy it to is the period, which is going to be the current working directory, which is the /app. So it's going to copy these two files from our local device and slam them into the app of our Docker environment. Now that we have access to the package.json, we need to install all of the necessary npm packages or dependencies that we need for our project. And since we have access to the Node.js and consequently npm ecosystem, we can do that very easily. So we're going to install the dependencies. Now traditionally, we've typed npm install and then we've specified the name of the package. However, if we just want to install every dependency inside of our project, we can do that using the npm install command, and we don't have to specify any packages. And what that will do is it will just read our dependencies list and install them all. And since we have access to that file inside of our Docker environment, we can just use the run command, and we can run the npm install command inside of our Docker environment, and that will install all of the dependencies. Now that we have the dependencies installed, we're good to copy the rest of our application across. So we're going to copy the rest of the application code. And that is once again a copy from the source destination, which is our current file, which is chapter 4, to the destination, which is the /app directory. The period is the current file, and this is the current working directory inside of our Docker environment and the destination. So that's going to copy all the remaining source code across. Now the reason we separate these two commands is because the way that a Docker image is built is from the top down. And if we change some of our source code, when we next go to build that image, it will rebuild our container from any files that have been changed. If all of this stuff is exactly the same, which it likely is, we're probably not going to be installing any more packages, and that means all of our dependencies will remain consistent. Docker is clever, and so it can cache all of this build information, and it can just rebuild the image from the changed line. So technically we could just copy everything in one go, but that means that when we make changes to our source code, we would then consequently have to recopy this line and reinstall all the dependencies, which we can avoid if we just copy first the package.json, then install the dependencies, and then next time we change our source code, we can just rebuild our image from this line down. You don't have to do this, but if you just want to make the process of building your containers slightly more efficient, this is a good way to do it. So this line copies our entire source code across to the container. Now that we have copied all of our source code across, what we need to do is expose the port that the app runs on. Now what this means is that when we create this Docker container and we run our application inside of it, it's essentially walled off from the rest of the world. And what we need to do is open up its ports, and we map an external port to an internal port, and we'll see how we can do that later. But the point is, we need to expose the port that we run our application on. For consistency, I'm going to do 5003. And we can see just here, this expose command exposes the port that the container should listen on. Define network ports for this container to listen on a runtime. So once again, just to summarize this line, we need to tell our environment to open up this port to incoming network requests from whatever source. If we didn't have this line, it would be an impermeable barrier that we couldn't send network requests into. So it's just like opening up a wormhole between our real environment and this Docker environment. And then, once we've exposed this port, we are now good to boot up our application inside of this Docker container. So we're going to define the command to run your application. And the way that we do that is with the command, cmd. And in here we have an array of the strings or words needed to boot up our application. Now the way that we typically run a file is we say node, and then in a separate command we specify where node can find the executable file, which in this case is the ./source/server.js file. And you'll note that that is fairly equivalent to what we see inside of our script. We say node, and then we specify the file, but we obviously have all of this jargon in the middle. Now, because in Chapter 4 we're using Postgres and we're not using any experimental features inside of Node.js, we can remove all of these different lines. So that's super handy. So we can have a very simple startup script. We don't need any of these experimental features. And consequently, this is the command that is going to boot up our application. And I actually think these are meant to be the double quotation mark, not the single quotation mark. So I'm just going to change that very quickly, just like that. So that is now happy. And that is going to boot up our application inside of this container. And it's going to listen to incoming network requests on port 5003. So that is officially the instruction sheet that our container needs to get our application up and running. Now this is super cool because anyone on any operating system can suddenly start up our application inside of this little environment. Another good example is that if you wanted to run Postgres, normally what you would have to do is install Postgres on your device, and then you can get Postgres up and running. In this case, at no point have we installed Postgres, because our Postgres environment is going to run inside of its own little Docker container. And so we can just actually tell Docker to create an environment with Postgres installed, and we can just refrain from installing it on our device. So it just makes it super easy to, deploy your code to a different environment for someone else to download your GitHub repo, run it on their device. And at the end of the day, for us just to not have any software installed on our computer aside from Docker, and we can still boot up these amazing applications. So Docker is super handy, and it is ubiquitous, which is a good word. So now that we have this instruction sheet, what we have to do next is actually build this container. We've just created the instruction sheet to build this container. However, one thing we need to do first, since we're not running these experimental flags, we need to make sure that we're not involving SQLite, Node SQLite anywhere inside of our project. Currently, we still have the import line for our original SQLite database in our routes files. And that means that when we boot up this container, it's going to try and execute this database as well as having a Postgres database. Now the problem with this is that since we haven't enabled at these experimental flags, that's going to break our container. So we don't have to delete these files, we just need to delete the imports from the auth routes and the to-do routes to that database file, and then it's just going to sit there not doing anything. So that is absolutely fine. So we'll just remove those two lines from our code base, and now we're almost ready to build our container. The one last thing we need to do before we actually build our container is finalize our Prisma setup. Now the way that we're going to do that is from our terminal, and we need to run a command that is going to generate a config file for our Prisma client. Now the reason we have to generate this config file is because it's specific to our schema, which is our database structure essentially. And every time we change or modify this schema, we need to rerun this command. And the command can be found within the readme.md file if you're looking for it later. There's a whole instruction sheet just here on how to get this up and running. But essentially what we're going to do from inside of the chapter 4 directory, now that we're finished with the schema, is we're just going to run npx prisma generate and hit enter on that command. So now that it has generated that Prisma client and it's saved it inside of our node modules, that is all done. We are almost ready to build our containers. Currently, if we went ahead and built our containers, we would build our Docker file for this Node.js application, which is brilliant. However, the problem is that doesn't help us with our PostgreSQL database. Now, to configure a Postgres database inside of a Docker container, you essentially just need to run this first command. And because it's just one line, we can actually do that from what's known as a compose.yaml file. Now, where a Docker file is essentially an instruction sheet for creating one Docker container, when you have an application that uses potentially, numerous or even tens of different containers or environments, you need to define a configuration sheet to boot up all of these Docker environments. So what we're going to do is create a new file, and that's going to be called docker-compose.yaml. YAML, and I'm going to hit enter on that. And so where the Docker file is the setup instruction sheet for a singular Docker container, the docker-compose.yaml is a configuration sheet for our conglomerate of Docker files or individual containers. It's kind of like a glorified specs sheet. Now, there's a few different lines in here, and I like to think of it as kind of like a bullet point specification list. So we just have a bullet point and some tab indentation of all of the different specs we need to get all of our containers up and running in one fell swoop. So in here, the first parameter we have to specify is the version, which is going to be version 3. That line doesn't really mean much. Underneath that, we have a line that means a whole lot more. It's called services. Now, inside of services, underneath that, we're going to tab across, we're going to indent it, and this is where we define the configuration for all of our different containers. The first one is going to be the app container, and that is going to be the Node.js Docker file that we just created. So in here, I'm going to use a semicolon, enter, and then tab across once again. It's like indentation instead of using bullet points. Now, this app needs what's known as a build line. Now, we use the build line when we have a Docker file to build that container. And the path to that Docker file is just the period, which is the current directory. So it's going to look in the same directory as this YAML file, and it's going to find the Docker file, and that's the instruction sheet it's going to use to build that container. Now, underneath that, at the same indentation, we're going to have a container name, and that's just going to be to-do-app. Underneath that, we're going to have an environment parameter. Now, the environment parameter is for specifying the environment variables. Where in the previous projects we use a .env file, in this case we can do it directly from this specs file, which is super handy. Now, the first parameter we're going to need in here is a database, and this is all uppercase, _URL. Now, if you remember, inside of this schema.prisma, we had to provide a URL, and this was the default code created when we created this file, so this was already there. And it's looking inside of the environment variables for a database URL. Now, in chapter 3, our server and our database were one unified entity. However, in this project, we have one container with our database and a separate entity that has our server. And so we need to provide our server with an address to locate our database container. And that is the database URL. So in this case, the database URL is a little bit complicated, and I'm actually just going to copy it across. So once again, if you head over to the GitHub code, you'll be able to find this line. Just look for the docker-compose.yaml file and copy this line across. And this is the address we need to find our database. And if you do check out the GitHub, be sure to star the project. Love that support. So this will give our node server an address through which it can communicate with the database. Now, the second environment variable we need, I added a little quotation mark there. The second environment variable we need for this app is the JWT secret. And that's an environment variable we're familiar with from chapter 3. And in here, I'm just going to provide a random string. your JWT underscore secret here. Now this string can be any string. It could be a jargon string, a whole bunch of random mumbo jumbo, or it could be something specific to you. But once again, environment variables are secure, they are protected, and it's something that only you should have information to. So whatever string you choose to put here, whatever selection of characters, just make sure that it's only available to you. Equally, you could just use this for development. It's secure on your device, so it's not going to be a huge issue. The third environment variable is called the node underscore env. So that's the node environment. Now typically there's two environments, sometimes there's three. One is development. So when you boot up your application in development, that's going to be the development environment. Another example would be a production environment. And a third one might be staging, which is typically somewhere in between. It's the environment prior to deploying your code to production. Now the reason we like to specify this as an environment variable is because sometimes we have code that runs specifically in development, other times we'll have code that only runs in production. And so if we specify it inside of the environment variables, that just allows us to have the same code base but change one line, and that's going to basically specify what environment that we're in. So in this case, it's going to be the development environment. Finally, we're going to specify the port environment variable, which if you recall inside of our server.js, we read the port for our app to listen on from the environment variables under the port key. We obviously have a backup of 5003, and in this case, the port for me is just going to be the same, 5003. So that is our environment variables complete. Now underneath, the next parameter we have to specify for our app is the ports. Now this is called port mapping, where what we do is we match an external port to an internal port. And just like exposing, we basically set up a configuration for an external network request to meet a port, and we match that to an internal port. So in this case, I like to keep them the same, and that's going to be a string, and we're just going to match 5000 in your case, or 5003 in my case, to port 5003. So this is the external port on our container, and this is the internal port that we're going to match it to, or map it to. Underneath the ports, the next parameter is going to be a depends on field. Now obviously, our server depends on our database. Now we haven't configured the database service just yet, but we will do that very shortly. But all we do is we just tell it that it depends on the database. So one is dependent on the other, and that is going to interconnect the two of them. And then the last field we need is a volumes field. Now the volumes field, essentially what it does is it creates a database or a storage or a history record of our server. So if we didn't have a volume, every time we booted up our container, it would be a blank slate. If we do have a volume, that is a place for us to save the previous state of our container so that when we shut it down and we boot it up again, we can just read back from where we were. So in this case, the storage for basically where we're at is going to be in this directory right here. That is the volume, and that is just going to persist any configuration, any data, any information that is available inside of our container. And this would only be erased in the case where we would actually delete the container and rebuild it from scratch. So it's important to have a volume so that your app can remember, essentially. And that is our first app service complete. Now the second service, which has to be at the same indentation as the app, is going to be called the database. Now the database doesn't have a build file because we haven't specified a Docker file for it. And as I said earlier, instead what we're going to do is just build it directly from an image. Now the image we need for our Postgres database is the Postgres version 13-Alpine. And obviously this image is one tab indented from the database, which is one tab indented from the far left-hand side. The indentation is super critical for this file, so if you're uncertain, be sure once again to compare it to mine in the GitHub repo. Now that we have the image, which is basically all the setup we need for creating that environment with Postgres inside it, we're going to give the container a name. So the container name is going to be the Postgres database. And underneath that, we're going to have some environment variables. Now these ones are going to be a little bit different. Essentially, the first one is going to be a Postgres user, and this is all uppercase. And the username is going to be Postgres. So we're essentially just defining the login information if you wanted to be a hacker and modify the database behind the scenes. So it's just all of these security credentials for the database. The Postgres password, _password, is going to also be Postgres. And finally, the Postgres database name is going to be called to-do app. And this to-do app right here has to match this to-do app at the end of the database URL. So they need to match perfectly. Now with that done, we can specify the ports, and the port mapping I want for our database. Standard practice or convention is to match 5432 to port 5432. So that's just going to map port 5432 on the outside or the external port for our container to the same port on the inside of our container. And once again, if we come up to our URL, we can see that the port we are using for our database URL is 5432. And as I said, that's just convention and we are going to stick with it. Now the last thing we need, and it's arguably more important in the case of our database, is to specify the volumes, which is once again going to just create a data persistence for this container. If we didn't have this, once again, every time we rebuilt our container or reran it, it would be starting from scratch, and that's not very convenient when you're working with a database. We need an environment that's going to persist data until we literally delete that container off the face of the earth. Now the volumes URL where this data is going to be saved is a little bit more complicated in this case. It's just going to be postgres-data /var/lib/postgresql/data. That's where all of the information is going to be persisted so that when we reboot up our container, we can pick up right where we left off. Finally, we're going to have one more field, and this is going to be at the far left-hand side, so no indentation. And that's just going to be called volumes, and that's going to be postgres-data, just like that. And with that, our specs file, our compose.yaml file, is complete. So now that we've configured this specs file, which basically is an instruction sheet on how Docker can boot up every container needed for our application, we can actually go ahead and build these containers and finish our project. Now there's a few steps required to build these containers and consequently get them up and running. One such example is when we have our Postgres container working, we need to then go into it and make sure that the tables are created within inside that database, and we'll see how that works shortly. All of the commands that I'm about to run are available within the Get Started section of the readme.md for chapter 4, so you can find all the commands we're going to be using just there. It is a bit of a step-by-step process, but once it's done, it's complete, and you now have this brilliant application. So we've completed the Docker Compose YAML. Let's go ahead and build all of these containers. Now with Docker open in the background, the first command we're going to go ahead and write is called docker space compose space build. Now what this is going to do is it's going to build our containers from that compose.yaml file. And here we can see it's starting off by running all of those Dockerfile commands first for our app, and then it also does it for our Postgres database. Now with these containers built, we are now ready to boot them up based off the images that are created or the snapshots of these completed environments, and we can go ahead and run these virtual environments. However, before we go and run them both together, we now need to make sure our database is updated to match the schema.prisma file, or essentially the tables necessary for our database. Now the command we're going to use for that is a little bit complicated. It's docker compose, but instead of running build, we are going to run our app, and inside of the app, we're going to execute the command npx prisma migrate dev --name init. Now what this command is going to do is it's going to migrate or run a migration for our database. And that is going to read our schema file, and it's going to create the first version history for essentially any modifications made from our database, which in this case is going from a completely blank database to having the necessary tables we need for our application. So I'm going to hit enter on that command, and we can see what has happened is it has run our Postgres container, executed this command, and it has created the to-do table and the user table. So that is excellent. We can see that it's also created a migrations folder inside of our Prisma file. This is absolutely normal, and it's not something that you want to meddle with. It's just the record history of any modifications made to our database. So that is all done. Now that we have finished that line, our database is set up to, have all the tables we need for our project. We can go ahead and boot up our 2 Docker containers. And the command we use for that is docker compose and then up. Now you can also specify a /d flag, and what that's going to do is it's just going to boot them up in the background and give us access to our terminal again, but I'm not going to use that in this case. So if I go ahead and hit enter, we can see now we are running 2 services. We have a container called PostgreSDB and another one called to-do-app. And we can see that our to-do app has actually executed that console.log that we have when we tell our app to listen on port 5003. That is now running. And even cooler, if we open up Docker Desktop, we can see here we have chapter 4. We can click on that. We have our 2 containers running, and we have a nice log that we need for our whole project. So that is absolutely brilliant. You could look at the logs for each of them specifically by clicking on each one, but here we have just a global log for our containers. And with that done, that is actually our app running inside of these 2 containers. And so we should be able to, I'm just going to clear out any tokens that we have saved just here so that we can start from scratch. So let's refresh this page. We have absolutely nothing. Local storage. I'm going to delete that token. So we have our blank application. We can see that it is being served up on port 5003, which is super cool because I'm not running npm run dev. Like our application is running inside of this container and it's serving up our application. I could go ahead and try to log in, and that fails to authenticate, which means that our backend endpoints are working. What I could also do is I could come into our client emulator right here, our to-do app.rest, and I could run this register command. I could emulate this client request. And we can see that that works, and that registers us, and it gives us back a token. I could try log in again. I haven't actually registered a user inside of the application, but that client emulation has created that entry inside of the database. So now when I submit, I'm actually logged in. And we can see that we even have a to-do, which means that our backend inside of this container wrote to our Postgres database. I could go in here and add a new to-do, and I could say that this first one is complete. And now I can refresh the page, and we can see that this data is persisted inside of our database. So that is super cool. And it gets even cooler. What I could do now is I could go ahead and delete this token once again, refresh the page. That's going to log us out. And I could create a new account. And this is going to be test@gmail.com. Here's a basic password, and I can log in. And we now have a new user created. And what we're going to do now that we have made all these entries to the database is we're going to see how we can log directly into the database, which is a place where we can modify it directly using SQL queries. So if I come up here, we have all of this logging going on inside of our Docker container. And what I'm going to do is create a new terminal instance, and that's going to keep this one running in the background, but it's also going to give us a terminal that we can run some new commands in. Now to log in directly to our database is a slightly complex command, and it is once again available inside of the readme.md file. But essentially what we do is we write docker execute exec -it, and we specify the name of the database, which is Postgres-DB. We specify the user, which is Postgres. If you recall, that's what we specified in the environment variables. And then we specify -d, and we call the to-do app container. Now, if I run this command, it's going to log us into our database. And I realize I made a mistake just there. I missed out one command. Just after the DB, we need to have a PSQL, which is the PostgreSQL command. And that is important to put in front of all of these flags. So if I go ahead and run that in, that logs us in directly to our database where we can go ahead and run SQL commands. Now, the first SQL command I'm going to introduce you to is the \DT. Now, if I hit enter on that, that's going to show us all the tables available inside of our database. So just here, we can see we have 3 tables. One is a history of our migrations, which are the modifications made to our database or the changes made over time, kind of like a version history. We also have a to-do table, which has all of our to-dos, and we have a users table. And what I could do now is run the select query to read all the entries inside of a table. I could say select everything from the to-do table. And what we're going to do here is just wrap to-do inside of the double quotation marks, and that's just going to match the casing, which is going to be super important. And when you run these commands, you always have to finish them off with a semicolon. So if I hit enter on that, we can see here we have a table that shows all the data inside of our database. We can see we have 3 tasks. We can see the first one is go to the gym, and we can see that's true, and we can see that's currently incomplete. Its completed status is false. We can see that we have hello, add your first to-do, and that's true. If you remember, I clicked complete when we added our first to-do, go to the gym. And we can see that both of these to-dos are associated with our first created user. And then we can see we have another to-do, and that's associated with our second user. And then if I wanted to exit out of this database, all I do is I write the quit command, and that gives me back access to my terminal. And you could log in, you could actually run a whole lot of CRUD actions using SQL commands directly on the database, and all of these changes would be reflected in the front end. But ultimately, that is our backend application complete. We've seen how we can build a server. We can set it up to listen to incoming requests to its port. We can add authentication and database interactions. We can serve up a front-end application that can create network requests between the front end and the back end. So it's ultimately a full stack application. We've added middleware to add authentication protection to a whole lot of our CRUD to-do endpoints. We've created Docker containers for 2 different environments. One is our server and one is our PostgreSQL database. And we've seen how we can boot them up and run them as a collective application for development. And this is such a cool backend project to have, because a lot of the backend infrastructure you would find at almost any company is just going to be a slightly more sophisticated or equivalent version of what we have just coded here in this full course. So I'm super proud of you. Well done for persisting to the very end. Congratulations. You should pat yourself on the back. Learning backend development is, takes a lot of time and practice, but now you have an absolutely amazing code base to reference as you build out some absolutely amazing backend applications in future. Thank you guys so much for sticking with me throughout this course. I hope you've had a thoroughly good time. And if you have enjoyed the course, don't forget to smash the like and subscribe buttons. I'll catch you guys later. Peace. Learning to code? If so, be sure to check out the Learn to Code roadmap or dive straight in with these videos. That's a good one.